Hello there and welcome to Just About Earth, where curiosity settles in quietly, the science takes its time, and the world becomes just a little stranger the longer you look at it. Tonight, we are turning our attention downward, inward, and occasionally sideways into one of the most unsettling and fascinating ideas our planet can offer. What if Earth is hiding things we were never meant to find? Not in the dramatic sense of a trapdoor opening beneath your kitchen floor, although that would certainly make for an inconvenient evening, but in the slower and more persistent sense that the ground beneath our feet may still be keeping its own counsel. For all our satellites, sensors, drills, maps, and confidence, we may know far less about this planet than we like to imagine. It is easy to think of Earth as familiar. After all, this is home. We walk across it every day. We build roads over it, tunnel through it, farm it, mine it, name it, divide it into property lines, zip codes, borders, and geological surveys. We like lists and labels. We like the comfort of saying this mountain range is known, this cave is mapped, this coast is charted, this desert has been crossed, and this stretch of ocean floor has already been scanned. It gives the impression that the world has been accounted for, tidied up, and filed away. The map is coloured in, the blanks are gone, case closed. And yet that feeling turns out to be less a fact than a habit, because every so often the planet gives us a quiet reminder that it has not finished surprising us. A hidden chamber appears behind a wall no one thought to question. A fossil emerges from a rock that had sat undisturbed for millions of years. A city long assumed to be myth rises slowly from jungle, sand, or silt. A cave reveals bones, tools, handprints, footprints, or ash, and suddenly a piece of human history has to be rewritten by the simple inconvenience of evidence. There is something deeply humbling about that. One of the peculiar features of modern life is that we are surrounded by information to such an extent that it becomes easy to confuse information with completion. We can zoom from orbit to street level in seconds. We can pull up terrain models, weather maps, mineral surveys, seismic records, and satellite imagery while sitting in bed in socks that may or may not match. We can ask our phones where we are, how old the rocks are, what bird is singing outside, and whether it will rain before lunch. Useful, yes. Impressive, absolutely. But none of it changes the fact that Earth is not a tidy database. It is a layered, active, damaged, rebuilding, deeply old place. It erodes, folds, buries, freezes, melts, sinks, shifts, and covers its tracks with the casual efficiency of something that has had 4.5 billion years to practice. And perhaps that is where the unease begins, because hidden things are only charming up to a point. Lost treasure sounds lovely. A forgotten temple in a forest sounds cinematic. A cave no one has entered for thousands of years sounds exciting in the comforting way it sounds, when you're hearing about it from a blanket rather than crawling into it with a headlamp and a thin rope. But the phrase, "never meant to find," introduces a slightly different feeling. It suggests not just mystery, but timing. It asks whether some discoveries remain hidden because they are difficult to reach, or because the planet is very good at withholding them until some accident, disaster, or stubborn curiosity forces them into view. Not because Earth has intentions, of course. Rocks do not scheme. Mountains are not holding emergency meetings about what humans are allowed to know. But geology, climate, and time together can create the impression of secrecy so effectively that it is hard not to slip into that language. A valley stays inaccessible. A burial stays sealed. A coastline keeps sinking and rising. Sediment accumulates. Forest grows over stone. Ice locks something away for 10,000 years, then retreats by a few meters and reveals it at exactly the wrong or right moment, depending on how you feel about unexpected evidence of the past. So let me ask you, before we go much farther, where in the world are you listening from tonight? Are you in a city with pavement humming under streetlights, in a quiet town where the roads go dark early, or somewhere rural where the night still feels properly dark and the land around you seems larger than it does by day? And what time is it there, in your corner of the world? There is something fitting about that question tonight, because this idea of hidden Earth is tied to time as much as place. A thing can remain hidden not simply because it is buried, but because no one thought to look for it until the right century, the right storm, the right drought, the right collapse of a cliff face, or the right person with a brush and unreasonable patience happened to be standing nearby. If you find this kind of slow journey soothing, intriguing, or just a nice place to let your mind rest for a while, I'd be very grateful if you gave the video a like, maybe subscribed, and stayed a little longer with this quietly strange corner of the world. It helps this channel reach others who enjoy winding down with science, history, and the occasional reminder that our planet is under no obligation to explain itself all at once. And as always, I do hope this is interesting enough to hold your attention, but not so dramatic that it keeps you fully awake. Though if it does, at least you will have spent the evening in respectable company with a few caves, some buried cities, and a planet that has been withholding details for longer than our species has existed. One of the reasons this topic grips us so strongly is that it touches an old and persistent instinct. Humans are intensely responsive to hidden things. We always have been. We peer into cracks, open boxes, dig into hillsides, descend into wells, pry at sealed doors, and stare at landscapes wondering what lies underneath. Children do it almost automatically. Turn over a rock, lift a lid, open a drawer, look behind the curtain, ask what is in the attic, ask what is in the basement, and then ask why the basement is making that noise. Adults do it too, only with better equipment and slightly more paperwork. Archaeology, paleontology, geology, speleology, oceanography, even forensic science all grow in part from that same simple impulse. Something is concealed, it might matter. We should probably find out. Still, what makes Earth a particularly effective keeper of secrets is that concealment is one of its normal functions. Sediment buries, volcanic ash seals, tectonic motion folds layers over other layers, water fills voids, ice preserves, then crushes, then preserves again. Forests grow over stone walls, coral builds over wrecks, sand migrates, rivers change course, shorelines retreat, sinkholes open, cliffs collapse. Entire landscapes are erased and rewritten long before any human observer arrives with a notebook. When people speak of the world revealing something, it often sounds sudden, but the truth is usually slower and more physical. The thing was hidden because the conditions to expose it had not yet lined up. Then they did. Sometimes the trigger is almost laughably ordinary. A farmer ploughs a field and uncovers fragments of pottery or bone. Construction crews begin digging foundations for apartments or roads and discover tombs, ruins, tools, or footprints. A storm tears away part of a coastline and reveals structures that had been buried for centuries. A drought lowers water levels and forgotten villages, temples, roads, or graveyards reappear. A wildfire clears dense vegetation, and shapes in the land suddenly become visible from above. New imaging tools detect patterns in terrain that looked random at ground level. A cave system thought to be small turns out to connect to a far larger network. A cliff face crumbles, and from the broken rock emerges something with teeth, or hands, or writing on it. This is perhaps one of the more sobering things about discovery. It is not always the product of heroic searching. Quite often it happens because Earth shifted slightly, and stopped hiding a thing for long enough to be noticed. That detail matters, because it changes the tone of the story. It means the world is full not just of remote mysteries but of near misses, places where evidence sits just beyond sight until chance, disaster, or technology nudges it into view. The hidden does not always live at the far edge of exploration. Sometimes it is under a parking lot, sometimes beneath a cathedral, sometimes below a lake that used to be a valley, sometimes under your feet while you are queuing for coffee and looking at your phone. There is also the matter of scale. When people imagine undiscovered things, the mind usually jumps to something large and dramatic. A lost city, a giant cavern, a buried monument, perhaps something with pillars if the budget allows. But many of the most important hidden things are small. A tooth in the wrong layer of rock, a seed preserved in dry sediment, microscopic traces of ash from a long ago eruption, a smear of pigment on a cave wall, a pollen record in ancient mud, DNA extracted from bone fragments too broken to identify by sight alone. In science, the planet does not always keep its secrets in grand vaults. Sometimes it hides them in crumbs. A whole idea about the past can change because of something that fits in a gloved hand. That may be why the theme we are circling tonight is not just discovery, but readiness. Were these things never meant to be found, or were we simply not ready to notice them? That is a different question, and a more interesting one. Consider how often humans have walked past evidence without understanding what they were seeing. Fossils were once curiosities, then puzzles, then clues, then anchors for entire models of life's history. Ruins were dismissed as natural formations until survey work revealed streets, walls, irrigation systems, or alignments too deliberate to ignore. Cave markings were overlooked, misread, or underestimated until better methods showed their age and significance. There is a long history of the world presenting information that humans simply lack the tools, context, or willingness to interpret properly. In that sense, hiddenness is not only about burial, it is also about perception. Something can be visible and still remain effectively hidden if no one recognizes it for what it is. A landscape may contain traces of ancient engineering invisible to the casual eye, but obvious once LiDAR strips away vegetation. A broken shard may look like rubble, until someone understands the pattern on its surface. A deep seismic signal may sound like noise, until years later it becomes the basis for a new model of what lies under the crust. There are whole categories of things Earth has likely shown us before we were ready to read them correctly, which is mildly comforting if you enjoy the idea of science steadily improving its vision, and mildly unsettling if you consider how much may still be in plain sight, waiting for the right question to make it visible. The phrase "never meant to find" also invites another possibility, one that has less to do with forbidden knowledge and more to do with human psychology. Perhaps some things feel hidden because they remind us how incomplete our control really is. We are very fond of stability. We like the impression that the ground is fixed, the past is known, and the map is settled. Buried things challenge that. They suggest that beneath the neat surface of daily life are older worlds, older climates, older extinctions, older people, older disasters, all layered under the present like drafts beneath a final copy. A city stands over a settlement, over a ruin, over a floodplain, over older habitation, over sediments laid down before people existed. The world is not a flat stage, it is a stack. And when that stack is opened, even in a small way, it can create a peculiar mental jolt. A road cut through a hillside shows stripes of ancient seabeds, where no sea has existed for ages. A cave reveals the bones of creatures no human ever saw alive. A glacier recedes and leaves behind tools, clothing, pathways, or bodies from a colder age. The ordinary present suddenly feels thin. Not false, just thin. The supermarket, the station platform, the apartment block, the schoolyard, the field, all of it begins to seem temporary in a more vivid way. Not because everything is doomed, although geology has never been known for sentimentality, but because the planet is always carrying more history than the visible moment can contain. This is where sleepier stories about Earth often become more compelling than the louder ones. It is not necessary to invent monsters or secret civilizations with suspiciously polished stonework and excellent branding. The real world already offers a more convincing kind of strangeness. It gives us preserved footprints in places no footprints should have survived. It gives us shafts, chambers, tunnels, bones, seeds, skulls, tools, shipwrecks, fossils, volcanic tombs, and submerged walls. It gives us caves so isolated that species evolved there in darkness. It gives us landscapes that from ground level appear ordinary and from above reveal geometry. It gives us deep layers of rock that record oceans, deserts, impacts, extinctions, and recoveries in patient sequence. And perhaps most remarkable of all, it gives us these things unevenly, unpredictably, and often inconveniently, as if discovery itself were part of a much slower process that answers to erosion rather than deadlines. There is a practical reason for this too. Exploration is expensive, dangerous, slow, and selective. Humans have not looked everywhere with equal care. Some places are politically inaccessible, some are environmentally harsh, some are underwater, under ice, under cities, or under private land. Some are simply vast. Deserts can preserve and conceal at the same time. Jungles can consume architecture so thoroughly that entire complexes vanish beneath canopy. Ocean floors remain poorly known compared with the surfaces of some neighbouring planets, which is not a sentence that becomes less odd the more often you hear it. Even where we have data, interpretation takes time. A scan is not an explanation. A hole is not a history. A chamber is not a conclusion. Finding is only the beginning. Understanding is the longer task. So as we begin this journey together, it may help to set aside the most theatrical version of the question and listen for the quieter one underneath. Not, what single shocking thing is Earth hiding from us? But how does a planet keep secrets at all? How are landscapes able to withhold evidence for centuries, millennia, even millions of years, and then release it in fragments? Why do some traces survive while others vanish completely? How much of the human story is still beneath our feet, beyond our maps, or misread in our collections? How many worlds have been buried, flooded, collapsed, frozen, mineralized, compacted, or dissolved, leaving behind just enough to tease us and not enough to settle the matter cleanly? Because that is often how truth arrives from the ground. Not as a fully lit revelation, but as pieces. A wall line, a tooth, a sealed chamber, a broken inscription, charcoal in a layer of ash. Bones where bones should not be. A structure that looks natural until it does not. A tunnel that leads farther than expected. A signal beneath the crust that suggests water where no ocean should be. The Earth rarely hands over a complete explanation. It tends to provide clues and let us argue about them for decades, which is a very geological way of doing things, and perhaps that is enough for now. Not an answer, but a posture. A willingness to let the world be older, stranger, and less finished than it appears in daylight. To imagine that beneath the roads, fields, seabeds, cliffs, and forests lies not one hidden story but many, stacked in layers, sealed by pressure, accident, and time. Some of them we will uncover carefully. Some we will uncover by mistake. Some may disappear before we know to look. And some, sitting quietly under stone, sand, root, and water, have already outlasted empires, calendars, languages, and names, waiting with the patience only a planet can afford. And once you begin to think of Earth that way, not as a fully known backdrop, but as an active keeper of traces, one of the first things that changes is the map itself. Because even now, in an age that likes to imagine every surface accounted for, there are still blank spaces of a different kind, still places where the lines are drawn but the understanding underneath them remains surprisingly thin. It is one thing for people to keep secrets. We are surprisingly bad at it. We leave clues in our expressions, contradictions in our stories, records in drawers, messages in old phones, receipts in coat pockets, and the occasional very suspicious sentence that begins with, "Now, before you ask." Even our silences tend to say more than we intend. The Earth, by contrast, is much better at the whole business. It does not fidget. It does not explain itself too early. It does not panic and reveal everything to the wrong person at a dinner party. It covers, compresses, dissolves, freezes, folds, and waits. If something falls into its keeping, whether that thing is a footprint, a forest, a city, a species, or an entire coastline, it may remain hidden for far longer than any human institution could manage. In fact, one of the clearest lessons geology teaches is that concealment is not some unusual side effect of the planet. It is normal. The world is constantly covering its tracks, not because it is trying to mislead us, but because movement, burial, decay, and change are simply what planets do. That can be difficult for us to remember, because modern life creates the impression that information, once found, stays found. We scan a document, upload a photograph, label a site, store a sample, and imagine that knowledge has now entered a permanent and orderly state. But Earth operates on very different terms. A river does not care that something matters historically. A glacier is not especially interested in preserving context for future researchers. A volcano does not pause mid-eruption to think about cataloguing. Sediment accumulates grain by grain. Storms reshape coastlines with no regard for archives, and roots pry stones apart with a patience that no museum curator would admire. This means the past is not lying neatly beneath us in labelled drawers. It is mixed, scattered, sealed, crushed, baked, submerged, and occasionally dropped back into view by processes that are entirely indifferent to whether we were ready to understand what we were seeing. Perhaps that is why the idea of a hidden Earth feels so persuasive. It matches the evidence. Again and again, the planet has shown that it can keep hold of things more effectively than we can. Take something as simple as a footprint. On paper, a footprint is the least permanent of traces. It seems doomed from the start. One step in mud, one press into damp volcanic ash, one brief mark in sand, and then surely wind, rain, another foot, or the next change in weather would erase it. Most of the time, that is exactly what happens. And yet sometimes the conditions line up so precisely that the mark hardens, is buried, protected, mineralized, and carried through ages of change until someone uncovers it much later and realizes they are looking at a moment that should never have survived. A person walked there, or an animal did, in weather no longer present, on ground now turned to stone, under a sky nobody alive can reconstruct in full. The track remained. The walker did not. Earth kept the secret anyway. The same is true on larger scales. Whole settlements vanish with astonishing efficiency when wind, water, vegetation and time start working together. A wall collapses, then another. Roofs burn or rot. Sand drifts in. Soil accumulates. Seeds take root in cracks. Shrubs become trees. Trees die and feed the ground that covers the foundations beneath them. A flood lays down silt. Another flood does the same. Generations pass, memory shrinks, stories become vague. Then eventually the place is no longer a ruin in the local imagination, but simply a hill, or a field, or an odd rise in the terrain where the sheep seem unbothered and the grass grows a little differently. That transformation is one of Earth's most efficient tricks. It makes human work look temporary without needing to destroy it completely. It only has to blur it enough. This is worth sitting with for a moment because humans are obsessive markers of presence. We build roads, walls, monuments, borders, drainage systems, towers, harbours, tombs, terraces, wells and homes with the quiet assumption that they will hold a place in the world. Even the humblest path says, someone was here often enough to wear this line into the land. Yet across long stretches of time, the planet answers with a kind of practical shrug. It does not always erase. More often, it absorbs. Stone gets reused. Mud brick returns to mud. Timber disappears. Metals corrode. Canals silt up. Shorelines move. The city becomes ingredients again. And if anything remains, it may do so in fragments so modest that later people can stand above an entire buried district without the faintest idea of what lies below the paving stones. Water in particular deserves some appreciation here, if that is the right word for a force that can preserve and destroy with equal enthusiasm. Water hides things in several ways at once. It buries wrecks in silt, floods valleys, feeds the growth that covers old walls, and softens the edges of everything it touches, yet it can also seal. In bogs, low oxygen conditions can preserve organic material with unnerving fidelity. In caves, dripping mineral-rich water can slowly lock bones or tools beneath calcite. In deep marine environments, lack of disturbance can leave artifacts sitting in cold darkness for centuries, even millennia. Water is not loyal to one outcome. It is the sort of custodian who either loses the box entirely or keeps it in unexpectedly good condition, and you do not know which until much later. Ice is another master of delayed revelation. For long periods, it is one of the best hiding places on Earth. Once something is caught in snow that compacts into ice, it may disappear from the human story completely. Paths vanish, bodies vanish, tools vanish, entire surfaces of former movement and former life are sealed over. Then the climate shifts, the margin retreats, and objects begin to emerge not because anyone solved a mystery in dramatic fashion, but because the freezer door was opened by a warming world. That gives many discoveries a strange emotional charge. The hidden thing has not merely been found, it has been released. Sometimes in excellent condition, sometimes damaged in the process, but always with the unsettling implication that for centuries or thousands of years it remained beyond reach in conditions that no longer exist in the same way. And then there are caves, which may be the closest thing Earth has to locked cabinets. They are natural archives, but difficult ones. Some are obvious openings in a hillside, others are narrow, dangerous, airless, flooded, twisting or hidden behind collapses that make access a matter of luck as much as skill. Once inside, conditions can vary so wildly that preservation becomes selective in complicated ways. Paint may survive where sunlight never enters. Bone may remain where scavengers could not reach. Pollen, ash, charcoal and tools may settle into layers that remain protected from weather for astonishing lengths of time. But caves also mislead. A site can look empty until the right light angle reveals pigment. A chamber can seem fully explored until a crawl space leads farther in. Material can be reworked by water, disturbed by animals, or concealed beneath crusts and breccias that give little away from the surface. In other words, even when Earth appears to have handed us a room full of evidence, it still does so on terms that require patience, caution, and a willingness to admit how incomplete first impressions can be. There is something almost comical about how often the most significant finds begin with a very unglamorous moment of confusion. A farmer turns up an odd fragment while ploughing. Workers cutting a road notice shapes in the soil. Someone exploring a cave squeezes through a gap and finds there is more cave than expected, which is not always the comforting development it sounds like. Drought drops a reservoir low enough for old foundations to show. A storm strips away a beach and reveals timber, masonry or trackways. In the popular imagination, discoveries arrive with orchestras. In reality, they often begin with someone saying, "That's strange," while standing in mud. This is another reason Earth seems better at secrecy than we are. It does not merely hide things in dramatic places. It hides them in ordinary ones in such a way that they become visible only when circumstance peels back a layer at just the right time. Modern technology has improved our odds, certainly, but it has not ended the pattern. Remote sensing, satellite imagery, ground-penetrating radar, LIDAR, seismic surveys, chemical analysis, ancient DNA, and microscopic residue studies have all given us ways to notice what earlier generations missed. Forest can be digitally stripped away from terrain models. Buried walls can show themselves as faint differences in crop growth. Isotopes can reveal movement, diet, or climate history. Sediment cores can preserve sequences of environmental change more faithfully than written records ever could. But none of this turns the planet into an open book. At best, it teaches us how many pages are still stuck together. The hidden world expands as our tools improve, because each new method reveals another class of things we did not know how to look for before. It is less like reaching the end of a mystery and more like discovering the house has more rooms than the estate agent mentioned. That matters because Earth's secrecy is not only physical, it is interpretive. Humans have a long history of looking directly at evidence and failing to understand what it means. Bones mistaken for curiosities, ruins dismissed as natural formations, marks on cave walls overlooked, underestimated or attributed to the wrong period. Layers of ash or sediment recognized but not connected to the events that produced them. One of the quieter truths in science is that many hidden things were not hidden from sight so much as hidden from understanding. The object was there. The clue was there. Sometimes it had even been collected and stored. What was missing was the framework to read it. That should make us humble. It means there are likely things already in drawers, museums, field notes, and survey images that will matter much more in future than they do right now, once someone asks the right question of them. It also means that secrecy can be created by confidence. When people are too sure they already know what a landscape is, they stop seeing alternatives. A mound is just a mound. A depression is just poor drainage. A scatter of stone is just a field boundary. A strange alignment is coincidence. A cave is too small to matter. An underwater feature is geological. This is understandable. Most things are ordinary. If every bump in the ground sent archaeologists sprinting into action, the world would become very expensive very quickly. But habit creates blindness. And Earth is especially effective at keeping secrets because its most important clues often present themselves as ordinary until examined in context. A buried road is just a crop mark until it lines up with another. A cavity in rock is just a hollow until it opens into a chamber. A stain in sediment is just a stain until microscopic analysis reveals ash, blood proteins, seeds, or human activity. There is another reason the planet outperforms us in secrecy, and it has to do with time. Humans think in years, decades, maybe centuries if we're feeling historically ambitious and have had enough tea. Earth thinks in accumulation. A secret kept by people has to survive gossip, politics, accidents, fire, inheritance disputes, bad filing systems, and at least one relative who absolutely should not have been trusted with the box of papers. A secret kept by the planet has to survive chemistry, pressure, temperature, and movement, which sounds harsher, but in some cases is oddly more dependable. Once buried beneath the right conditions, an object may remain untouched not because it is guarded, but because nothing relevant happens to it for a very long time. Not no change at all, but no change that fully removes it. This is why the Earth can return material from ages so distant they barely fit in ordinary language. We say millions of years as if that were just another number, when in practice it is a duration so large that the survival of any trace across it should feel outrageous. Fossils are perhaps the best example of this mixture of brutality and fidelity. Most living things vanish almost completely. They decay, scatter, and re-enter the system in short order. Fossilization is rare, selective, and unforgiving, and yet when it happens, the result can carry anatomical detail across immense spans of time. Teeth, shells, bones, tracks, impressions, pollen, leaves, even the textures of skin or feathers under exceptional conditions. The irony is difficult to miss. Earth is not gentle with remains, and still it sometimes keeps a better record than any civilization ever has. Libraries burn, empires collapse, databases become obsolete. But a layer of sediment laid down under the right circumstances can hold a signal from a vanished ecosystem until a hammer, a road cut, or an eroding cliff brings it into view. This is why people sometimes slip into the language of intention, even when they know better. We say the Earth was hiding something, guarding it, revealing it, refusing to give it up. Strictly speaking, these are metaphors. The crust does not make decisions. The mantle has no policy department. Sand dunes do not coordinate media strategy. Still, the metaphors persist because the pattern is so familiar. A thing remains concealed through ordinary human time, through memory loss and cultural turnover, and then appears in a way that feels almost timed. A tomb survives looting but is found during modern excavation. A site sits beneath a city until redevelopment opens a trench. Ancient footprints appear when tide and light align for a brief window. A glacier gives up a body when warming reaches a specific threshold. It is very difficult not to read timing into such events, even when the better explanation is the quiet one. Conditions changed, and now the evidence is visible. What makes this all slightly more uncomfortable is that hidden things are not always pleasant. Lost temples and preserved mosaics are lovely, yes. Evidence of ancient trade networks, buried roads, forgotten settlements, and beautifully worked tools can feel like gifts. But the planet also keeps darker records. Mass death, collapse, sudden burial, drought, starvation, flood layers, impact scars, toxic pockets, dormant faults, buried waste, ancient pathogens frozen or sealed in places where time was not expected to resume its usual business. Sometimes what Earth keeps from us is not treasure but warning. A landscape can appear peaceful while containing the memory of a disaster that will recur. A lake bed can hold the record of past climate swings larger than any living generation remembers. A cliff can hide instability until the day it doesn't. In that sense, the planet's secrecy is not always romantic. Occasionally it is simply hazardous. And perhaps that is the most honest answer to the idea we began with. The Earth keeps secrets better than we do, because secrecy, in geological terms, is often just persistence plus indifference. The world does not need to lie. It only needs to continue being a place where things are buried faster than they are found, altered faster than they are understood, and forgotten faster than they are interpreted. We are temporary observers on an active surface, trying to reconstruct deep history from fragments that survived by chance and circumstance. Sometimes we succeed brilliantly. Sometimes we mistake a clue for a curiosity and move on. Sometimes we do not even realize the evidence was there until it has already been damaged, submerged, looted, melted, or built over. Yet even with all of that, discoveries continue, and that is its own kind of reassurance. The planet is secretive, yes, but not silent forever. Once you start thinking this way, even a familiar landscape begins to feel less settled. A field is no longer just a field. A shoreline is no longer just a place for gulls and wind. A cave entrance is not just a hole in rock. A patch of forest, a dry reservoir, an exposed cliff, a sinkhole opening after heavy rain, all begin to carry a second possibility. Not that there is always something extraordinary there, but that the surface may be thinner, historically speaking, than it looks. The present is only the top layer, and not always a very thick one. Beneath it are older surfaces, older lives, older climates, older mistakes, older absences. And once you grow used to that thought, it becomes harder to look at a map as though it were complete, because maps are very good at showing where things are, but much less good at showing what might still be waiting underneath the lines. Once you begin to suspect that the Earth is better at keeping hold of its hidden things than we are at finding them, the map starts to look different. Not wrong exactly, just overconfident. That may sound unfair to maps, which have done a great deal for us and very rarely complain unless folded badly, but they do encourage a certain illusion. A finished map gives the comforting impression of a finished world. Coastlines traced, borders inked, mountain ranges shaded, rivers named, roads numbered, depths measured, heights recorded. It looks complete in the way a neatly labelled cupboard looks complete, even if somewhere at the back there is still a mysterious jar nobody has opened since 2014. And yet a map, no matter how detailed, only shows what it was designed to show. It leaves out as much as it includes. Sometimes that omission is obvious, sometimes it is the whole story. The old phrase, blank spaces on the map, usually brings to mind an earlier age, when cartographers filled unknown regions with pale parchment and the occasional decorative sea monster, which was a wonderfully honest way of saying, we don't know what is here, but it may be damp and disappointing. There is something almost charming about those old blanks. They admit uncertainty openly. They do not pretend. The trouble with modern maps is that they often hide uncertainty beneath precision. A line can be exact and still be incomplete. A satellite image can be sharp and still miss what matters. A topographic survey can tell you the shape of the land while saying almost nothing about what lies beneath it, what used to stand on it, what was buried by it, or what has been quietly moving under it for millions of years. In that sense, the blank spaces never vanished. They just moved between the lines. That is one of the more important facts about Earth, and one of the easiest to forget. We have mapped the surface of the planet far better than our ancestors did, but surface is only one version of reality. The world has depth, literal depth, historical depth, geological depth, cultural depth. A modern map can show you where a hill is and say nothing about the city buried inside it. It can show the outline of a lake and fail to mention the drowned valley beneath it, the older road, the older village, the older shoreline that still exists in colder, darker water. It can show the smooth green spread of a forest and tell you nothing of the walls, mounds, causeways, terraces, canals, graves and foundations hidden below the trees. It can show a desert as open space, when in fact the sand may be sliding over roads, settlements, cemeteries, and entire landscapes of former life. The map is not lying. It is simply not obliged to tell you everything. This is not a criticism of cartography, so much as a reminder of its limits. Every map is an argument about what matters. Some privilege roads and place names, some privilege geology, some privilege elevation, soil, rainfall, vegetation, political boundaries, ocean depth, fault lines, or land ownership. None can hold the whole Earth at once. To make a map is to decide what to reveal and what to flatten into background. That is unavoidable. Without selection, the thing becomes unreadable. But it does mean that a map is less like a total portrait and more like a question posed in graphic form. Where is the water? Where is the slope? Where is the jurisdiction? Where is the hazard? Where is the infrastructure? Where is the resource? Ask a different question, and the blank spaces begin to shift. This becomes especially clear when technology changes the kinds of questions we can ask. A dense forest seen from above might once have looked like exactly that. A forest, full stop. Thick canopy, green texture, difficult ground access, and perhaps the assumption that whatever lay beneath would be equally natural. Then along comes LIDAR, using laser pulses to measure the surface through gaps in vegetation, and the same stretch of terrain suddenly reveals platforms, roadways, embankments, field systems, reservoirs, terraces, rectilinear alignments, and urban layouts hidden by trees. The forest was real, of course. The map showing forest was not false. But another landscape was there too, one that had remained invisible to the casual view. The blank space was not empty, it was layered. That layering is everywhere once you start looking for it. Cities are particularly good at hiding older cities, partly because people love building in the same useful places. Water nearby, defensible ground, fertile land, good harbours, crossroads, passable climate if one is lucky, and history has been feeling generous. Build there once, and later people will often build there again. Rubble is levelled, stone is reused, foundations are buried, streets shift slightly but not always much, and over centuries the ground level rises. Entire neighbourhoods can sink beneath later development, not because anyone intentionally concealed them, but because ordinary urban life kept happening. One generation paves over the remains of another, and the map politely updates the street names while saying very little about the deeper stack below the bakery, the tram line, and the place that sells coffee at a price that suggests the beans were personally encouraged by monks. There is also the problem of the underwater world, which remains a source of both scientific frustration and quiet embarrassment for a species that likes to think of itself as advanced. We have made remarkable progress, certainly. We map seafloor topography with sonar, satellites, autonomous vehicles, and ships that go back and forth with admirable patience over vast tracts of ocean. But the oceans are huge, dark, deep, dynamic, and not especially cooperative. Large portions of the seabed have been mapped in broad terms, yet high-resolution coverage is still uneven, and the ocean floor is not some static plane waiting to be tidied up. It is volcanic, fractured, sedimented, scoured, collapsed, uplifted, and draped in material from above. Shipwrecks vanish into silt. Ancient coastlines lie submerged from times when sea levels were lower. River channels continue into drowned continental shelves. Entire landscapes that would once have been dry land are now underwater, and much of what happened on them may remain hidden, because looking beneath the sea is expensive, slow, and technically awkward in ways that make rummaging through an attic seem positively festive. This should matter to us more than it often does, because much of human history unfolded near coasts, estuaries, and river mouths. These are attractive places if you're trying to fish, trade, travel, or generally avoid starving. But coastlines are not fixed. Sea levels rise and fall. Deltas shift. Storms remove one layer and deposit another. Tides do their repetitive but surprisingly forceful work day after day for centuries, which is a very effective way of reshaping the edge of memory. So when we look at a modern coastal map, we're not looking at a stable border between land and sea. We are looking at one moment in a negotiation that has been going on since long before our species learned to make trouble in organised settlements. There may be traces offshore of things people built, crossed, fished, buried, or inhabited when the shoreline was elsewhere. The lines on the map do not show that unless we know to ask for it. The same is true in deserts, though in a drier and dustier mood. A desert map can appear stark, clean, and entirely legible. Open terrain, dunes here, rock there, dry channels winding across the plain like half-erased pencil marks. But deserts are masters of selective display. Wind removes and deposits with maddening inconsistency. A structure can be covered, exposed, half covered again, then uncovered after a storm or a shift in prevailing wind. Ancient river systems may leave faint traces only detectable from the air. Burial grounds can disappear beneath drifting sand. Trade routes vanish when the water sources that once sustained them are lost or forgotten. Whole settlement networks can become legible only when a drought, a survey, or an unexpected exposure reveals them as patterns rather than isolated ruins. It is one of the stranger features of arid landscapes that they can feel both completely open and profoundly concealing at the same time. They show you everything and almost nothing, depending on the light and the question. Mountains create their own kind of blank spaces, not through smooth concealment but through difficulty. A mountain map can tell you elevations, passes, glaciers, ridgelines, and watersheds, but it cannot communicate the full practical truth of access. Sheer ground, unstable slopes, weather that changes in a sulk, snow bridges, crevasses, rockfall, altitude, remoteness, and the general inconvenience of trying to conduct careful science in a place that seems mildly offended by your presence. High places are excellent at keeping things from us simply because reaching them is hard, and staying there long enough to understand them is harder. Caves open in cliff faces. Ice patches preserve objects dropped centuries ago. Rock shelters hold traces of seasonal use. Fossils weather out from exposed strata. Yet much of this is discovered only intermittently because mountain terrain allows glimpses rather than easy comprehension. The map shows the shape, the mountain keeps the detail. Then there are the truly subterranean blanks, which remain some of the most literal unknowns on Earth. Beneath our feet lies a world of caves, aquifers, faults, magma chambers, mineral veins, subglacial channels, sinkholes, and deep crustal structures that we infer far more often than we directly observe. Drilling helps, but drill holes are tiny interruptions in a vast hidden volume. Seismic imaging helps, but it is interpretation built from waves, models, and probabilities rather than leisurely strolls with a clipboard. Ground-penetrating radar helps, but only under certain conditions and to certain depths. Even in well-studied regions, the subsurface can be surprisingly elusive. Cavities collapse where no one expected them. Water moves through networks not fully mapped. Old mine workings remain imperfectly recorded. Buried infrastructure, tombs, tunnels, and voids complicate the neat confidence of the surface plan. The earth below is not a simple basement under the house of the world. It is more like an extension built in darkness over several billion years by a contractor who refused to leave notes. If that sounds unfair, consider how often major discoveries occur not in exotic frontiers, but in places presumed known. Urban construction uncovers earlier settlements. Roadworks reveal burials. Reservoir levels drop and forgotten structures emerge. Drainage projects intersect paleochannels or peat deposits containing preserved material. Even in countries with long traditions of survey and excavation, the map of what lies below remains provisional. This is partly because disturbance is uneven. Some ground has been dug and redrawn many times. Some has remained relatively untouched by chance. Some is protected. Some is inaccessible. Some is simply too expensive to investigate thoroughly, unless there is a compelling reason. And I have a feeling there might be something marvellous under this shopping complex is not always the sort of sentence that secures immediate funding. There is a pleasing irony in all this. The more detailed our maps become, the more clearly they reveal what they still cannot show. High-resolution elevation data can expose subtle earthworks, but it can also raise new questions about formations that do not fit easy categories. Satellite imagery can reveal ancient field systems, but it can just as easily produce patterns that invite debate rather than resolution. Geochemical maps can suggest buried features. Magnetic surveys can hint at walls, kilns, ditches, fires, or voids. Yet each new layer of information expands interpretation faster than certainty. The map gets richer, and the blank spaces become more sophisticated. They are no longer only empty white zones marked unknown. They are now corridors of ambiguity, patches of unresolved data, suggestive anomalies, and places where we know enough to realise how much we do not know. This may be one reason the idea of discovered is often less final than people imagine. To put something on a map is not necessarily to understand it. A site can be recorded for decades before its significance becomes clear. A cave entrance can be known locally without anyone grasping the extent of the system behind it. A mound can be marked without excavation. A submerged feature can be detected without agreement on whether it is natural or cultural. A ridge can be geologically mapped while still holding fossils no one has spotted yet. We often speak as if finding and understanding occur in the same moment, but in practice discovery is usually layered. First something is noticed, then it is recorded. Then perhaps much later, after analysis, comparison, argument and more fieldwork, it becomes meaningful in a broader way. The blank space shrinks slowly, and not always in the direction expected. It is also worth remembering that some blanks are created not by lack of technology, but by lack of access. Political instability, conflict, restricted borders, protected lands, deep ocean jurisdiction, sacred sites, private ownership, funding priorities, and environmental risk all determine what gets studied and what remains in limbo. There are places where the map is technically available, but practically out of reach. There are regions where field seasons are short, permits complex, logistics punishing, and conditions hazardous enough to make researchers very aware of their mortality, which is rarely conducive to neat note-taking. There are landscapes where work cannot or should not proceed quickly. In those cases, the blank space is not simply ignorance, it is delay, it is restraint, it is the admission that not every mystery yields politely on schedule. And then there is memory, which is perhaps the least reliable cartographer of all. People forget routes, lose place names, abandon settlements, misremember coastlines, relocate shrines, retell origins, confuse one mound for another, and assign stories to landscapes that gradually drift from literal description into legend. Oral traditions can preserve striking truths over long periods, but they can also transform with use, which is not a flaw so much as a feature of human storytelling. Written records help, but they too are selective. One generation records taxes and ignores the ordinary houses. Another records kings and ignores the irrigation ditches. Another records a flood and not the smaller changes that made the flood possible. By the time modern investigators arrive with instruments and optimism, the map they inherit may contain both hard data and soft assumptions, and separating the two can take years. All of this means that the blank spaces still between the lines are not merely geographical. They are temporal and interpretive. They live in the difference between visible and meaningful, between recorded and understood, between surface and structure, between today's terrain and yesterday's world. The map says what is there now, or what was detectable when the survey was made. It may not say what used to be there, what lies beneath, what only appears seasonally, what is masked by vegetation, what has sunk below water, what is hidden by urban growth, or what no one yet knows how to recognize. A line can be clear and the reality beneath it still uncertain, and perhaps that is why maps remain so compelling. They are not merely inventories, they are invitations. Every contour suggests process, every anomaly suggests a story. Every gap in knowledge, no matter how small, carries the possibility that the world is still withholding some part of itself, not dramatically, not with orchestral menace, more with the calm persistence of a planet that has had a very long time to become complicated. We lay grids over the land and sea because it helps us think, travel, compare, plan, and build. But the grid is ours. The complexity underneath is Earth's. So the next time you look at a map, especially a modern one with its soothing precision and quiet authority, it may be worth remembering that completion is partly a design choice. The world does not come to us in neat legends and colour keys. It comes layered, altered, flooded, overgrown, buried, fractured, and occasionally reluctant. There are still blank spaces between the lines because a line only tells you where one thing seems to end and another begins. It does not tell you what is sleeping underneath. And in some parts of the world, beneath jungle, beneath sand, and beneath the slow work of centuries, what is sleeping there may turn out to be not just a feature or a ruin, but an entire city waiting for the surface to stop being so convincing. Some of the most convincing evidence that Earth keeps its own counsel comes from the places where entire cities have simply gone quiet. Not destroyed in the dramatic way films prefer, with a final scream, a single collapsing tower, and someone shouting the name of a loved one into a sky full of ash, but hidden more slowly and more effectively. Covered, swallowed, sealed, overgrown, silted up, flooded, forgotten, or reduced to such faint traces that later generations walked right past them without realizing they were crossing streets, walls, courtyards, harbours, staircases, and homes. That is one of the more unsettling things about lost cities. They remind us that a city, however solid it seems in its own time, is not really a permanent object. It is an arrangement. Stone, mud brick, timber, plaster, roads, drainage, storage, ritual space, politics, trade, noise, cooking smoke, arguments, taxes, dogs, dust, gossip, and poor municipal decisions all briefly organised in one place. Keep that arrangement going, and you call it civilization. Let it slip long enough, and Earth begins the very practical work of turning it back into landscape. Sand is especially good at this. It does not need to attack a city to defeat it. It only needs to move. Grain by grain, wind pushes material into courtyards, against walls, across roads, through doorways, into wells, over thresholds, and eventually over roofs once the structures weaken. In arid regions, where preservation can be unexpectedly good, but visibility can be treacherous, a settlement may vanish not because it was violently erased, but because it was patiently covered. Trade routes shift. Water sources fail or migrate. People leave, perhaps gradually, perhaps under pressure. Maintenance stops, a roof falls in, a wall slumps, another season of wind arrives, a dune edge creeps a little farther. Within a few generations, the place that once seemed central to daily life becomes a rise in the desert, then perhaps not even that. The remarkable thing is not that cities disappear this way. The remarkable thing is how often they do. There is a tendency to imagine lost desert cities as grand and theatrical, places of gold, caravans, incense and dramatic sunsets over columns. Sometimes they were impressive, certainly. Some were major trade hubs sitting at the junction of routes that linked distant regions by camel, cart, river or sea. Others were fortified towns built to control water, movement, taxation, or access to a valley. But many would have looked ordinary to the people who lived in them. Ordinary housing, ordinary storage, ordinary workshops, ordinary food refuse, and the same ordinary human problem of trying to keep dust out of everything. That normality matters because it explains why abandonment can happen without immediate legend. If a city is not the glittering centre of an empire but a practical place doing practical work, then once it loses that function, the memory of it may shrink quickly. Local people may know ruins are there. Travellers may mention them vaguely. A name may survive detached from the exact location. Then sand does the rest, smoothing the story until later generations are left with fragments, rumours, and a suspiciously shaped mound. Jungles accomplish concealment by the opposite method, where deserts strip and cover, forests engulf. A tropical landscape can make a human-built place disappear beneath life so thoroughly that from the ground it becomes almost impossible to read. Vines claim walls, roots pry apart masonry, leaf litter accumulates, humidity rots what is organic and stains what remains. Small clearings close over, trees rise through plazas, reservoirs silt up, causeways blur into ridgelines, stone carvings wear down under rain, moss and time until they become surface rather than statement. Standing in such a place, a person might be surrounded by architecture and have no clear sense of it, because the jungle is excellent at turning geometry back into terrain. It does not erase the city all at once. It wraps it until your eye stops recognizing design. That is why so many forested ruins were never truly unknown and yet remained effectively hidden. Local communities often knew of them. People farmed nearby, used stones from them, told stories about them, avoided them, revisited them, or incorporated them into living cultural memory. The hiddenness was not always total. What changed, especially in the modern period, was scale of understanding. A temple known in one area might turn out to be part of a much larger urban landscape when mapped more fully. A cluster of ruins in the forest might be only the monumental centre of an enormous network of terraces, reservoirs, roads, residential districts, and managed land extending far beyond what earlier visitors could appreciate on foot. In dense vegetation, the eye is a poor judge of total layout. You see what is directly in front of you, and what is directly in front of you is usually a great deal of leaf. This is one reason new surveying methods have been so transformative. Remove the visual clutter digitally, and whole city plans appear where before there seemed to be only scattered ruins and aggressive insects. There is something humbling in that. For a long time, many ancient cities in heavily forested regions were underestimated because researchers saw the monuments, but not the full infrastructure. Temples and pyramids are memorable, certainly, but cities depend on more than ceremonial architecture. They need food systems, movement corridors, storage, labour organisation, water control, household space, and ways of connecting one population cluster to another. Jungle concealment can hide precisely those broader features, and once those are hidden, modern observers may mistake a dense engineered landscape for sparse settlement. Then LiDAR or painstaking regional survey reveals causeways, terracing, canals, walls and habitation zones on a scale that forces reassessment. Suddenly the city is not an isolated ceremonial island in a sea of wilderness. It is the centre of a managed environment and an urban network large enough to change our idea of what that civilization was capable of organising. The sea, meanwhile, hides cities with a different sort of finality. When a city goes underwater, it leaves the category of ruins most people can casually visit and enters the less convenient realm of diving equipment, sonar, marine sediment, currents, corrosion, low visibility, and logistics that seem designed specifically to discourage overconfidence. Submerged cities are often discussed as if they sank all at once in some dramatic moral lesson, but many did not. Sometimes sea level rose gradually over centuries after the last ice age, drowning coasts, estuaries, wetlands, and the human use of those places with no single catastrophic day to remember. Sometimes earthquakes or subsidence lowered land relative to the sea. Sometimes storms, tsunamis, or coastal erosion tore apart already vulnerable settlements. Sometimes harbours silted, channels shifted, and the urban centre moved or died while the sea claimed what remained. In every case, once water covers a place consistently, the difficulty of observation increases sharply and memory begins to detach from location. Ancient ports are especially vulnerable to this kind of slow disappearance. Harbours are useful for obvious reasons, but the shore is restless ground. Sediment builds and moves, quays subside, breakwaters collapse, storms scatter stone, marine life settles over surfaces, ship traffic changes channels. What was once a bustling waterfront becomes a dangerous shoal or a few submerged blocks that local fishers know to avoid unless they enjoy unexpected repairs. Later, when archaeologists arrive with maps, old texts, and a justified sense of curiosity, they may find that the shoreline described in historical records is no longer the shoreline at all. The city they seek is offshore, buried beneath mud, or split between land and sea in a way that only makes sense once geology joins the conversation. That combination of archaeology and geology is crucial. Lost cities are rarely lost for purely historical reasons. They are lost because physical processes change the setting faster than memory or record keeping could fully keep up. A trade route dries, a river avulses, the coast retreats, a drought undermines agriculture, a harbour silts closed, a delta migrates, a quake drops ground level, a sand sea advances, a forest expands over abandoned terraces. In other words, cities are hidden not only by forgetting, but by environment. That is important because it removes some of the false mystery. We do not need to imagine a city cursed or intentionally concealed by some sinister hand. Very often it is enough to picture ordinary dependence on water, soil, trade and stability meeting the very unordinary persistence of climate and geology over centuries. The city loses its support systems, is abandoned or reduced, and then the earth takes over archiving duties. Even when cities are rediscovered, they rarely return to us in full. What emerges first may be the most durable parts: stone walls, paved roads, foundations, reservoirs, harbour blocks, statues, ceramics, inscriptions if luck and circumstance have been unusually kind. But the life of the city was always more than that. Sound does not fossilise easily. Smells are poor at surviving bureaucracy, let alone centuries. Timber roofs vanish, fabrics rot. Food spoils, unless charred or sealed under exceptional conditions. Written materials disappear unless preserved by dryness, carbonisation, burial, or simple miracle. So every rediscovered city is partial from the start. We see its bones first. The flesh of routine has to be inferred from traces. That is why archaeologists spend so much time on things outsiders may find modest, even disappointing. Seeds, trash pits, drainage patterns, animal bone fragments, floorware, residues in jars, soil chemistry, post holes, and broken tools are often better guides to how a city functioned than a dramatic staircase ever could be. This is one reason the most meaningful discoveries are not always the most photogenic. A buried palace makes headlines, understandably. But a neighbourhood of ordinary houses can tell us more about density, diet, social organisation, inequality, domestic labour, fuel use, family structure, and daily rhythms. A harbour installation can change our understanding of trade. A buried canal can reveal engineering skill and water management. A street grid can speak to planning and authority. A midden can quietly embarrass grand historical narratives by showing what people were actually eating, while elites were busy dedicating monuments to themselves. Lost cities are valuable, not because they confirm our fantasies of grandeur, but because they complicate them. They show that urban life in the past was often larger, denser, better organised, more adaptive, and sometimes more fragile than earlier assumptions allowed. It is also worth noticing how often rediscovered cities force us to reconsider the phrase empty land. Again and again, landscapes once described by later observers as wild, untouched, or marginal turn out to hold the remains of extensive human occupation and management. Terraces appear on slopes that looked natural. Road systems connect settlement clusters across forest or steppe. Reservoirs reveal long-term hydraulic planning. Artificial mounds turn out to be platforms, houses, or defensive works. Ancient field systems emerge beneath dunes or peat. A place imagined by modern eyes as remote may once have been a centre. This is not merely a correction to the map. It is a correction to attitude. We are often far too quick to assume that absence of visible ruins means absence of substantial human history. Earth benefits from that assumption, because concealment becomes easier when later people think there is nothing significant to conceal. There is another quiet lesson in submerged and buried cities, and it concerns memory. We like to imagine that important places will surely be remembered, because surely people would not forget something so large, so central, so apparently solid. But memory does not work like a cadastral survey. Communities move, languages shift, catastrophes break continuity, religious meaning changes, capitals relocate, trade bypasses former centres. A once crucial harbour becomes a marsh. A once productive oasis fails. A dynasty falls and later inhabitants reuse the stone without preserving the name. Stories remain, but stories are mobile. They detach from exact coordinates. A city may survive as legend long after its location becomes uncertain, or its ruins may survive with no stable story attached to them. What the earth buries, time often helps mislabel. And then there is the role of accident, which remains embarrassingly important in serious research. A city may sleep undisturbed for centuries until a road project cuts through it. A drought lowers water levels enough to expose masonry. A storm strips away sediment. Or a new survey method happens to be applied in the right region at the right moment. This is not an argument against careful planning. It is simply a reminder that discovery often depends on coincidence meeting preparedness. Someone has to notice the anomaly, ask the second question, run the follow-up survey, compare the records, and take seriously the possibility that beneath the apparent surface lies something much larger. Earth does not offer up its hidden cities with little signs. It offers them in fragments, and humans do the rest, usually while arguing about interpretation, permits, funding, and whether the geophysical data really mean what the enthusiastic person in the corner insists they mean. That argumentative stage is important too, because rediscovery is not the same as understanding. Once a city is identified, a longer process begins. How large was it? Over what period was it occupied? Was it continuously inhabited or episodic? How did it obtain food and water? What trade networks linked it outward? What political system held it together? Why was it abandoned, transformed, or submerged? Was its decline sudden, staggered, seasonal, contested, or almost boringly administrative? These questions matter because cities are not just places, they are systems. If you want to know why one disappeared beneath sand, jungle, or sea, you need more than a date and a dramatic aerial photograph. You need climate history, settlement archaeology, paleo-environmental evidence, texts where available, engineering analysis, and a willingness to accept that sometimes multiple causes arrive together like uninvited guests. There is a reason this subject continues to fascinate people who would otherwise claim they are not very interested in ruins. Lost cities give visible form to a thought most of us prefer not to dwell on too often, namely, that permanence is often just maintenance with good public relations. Cities endure only while energy continues to flow into them. Water systems must be managed, roads repaired, waste removed, trade maintained, political order enforced, negotiated, or at least limped through. Once those systems weaken, the city does not become a romantic ruin overnight. It becomes vulnerable to ordinary physical processes, which are far more relentless than any invader. Sand does not negotiate. Tree roots do not care about dynastic legitimacy. Rising water does not make exceptions for architectural heritage. The earth does not hate cities, it simply outlasts them. And still, for all that, there is something oddly reassuring in the fact that cities can sleep rather than vanish completely. Beneath sand, under forest, below water, traces remain. Streets hold their line. Foundations keep their shape. Reservoirs remember where water used to be controlled. Harbour stones stay where labour once placed them. Even when the city is fragmentary, it persists enough to challenge the comforting arrogance of the present. We're not the first people to imagine our settlements as fixed points in the world. Others did too. They built carefully, planned seriously, worried about supplies, weather, trade and defence, and assumed tomorrow would resemble today closely enough for the work to make sense. Then conditions changed. The city slept. And centuries later, someone with a trowel, a sonar array, a laser scan, or a great deal of stubborn patience found part of it again. Which leaves us with a practical conclusion. If Earth can hide entire cities this effectively, sometimes in plain landscapes, and sometimes under environments that seem to erase all trace, then it is entirely reasonable to suspect that the urban past we know is incomplete in ways we are only beginning to measure. There are likely more settlement networks beneath forests, more drowned coastlines offshore, more desert routes under sand, more layered towns under modern cities, more modest places whose importance has not yet been recognised, because they lack a dramatic facade and have instead preserved the quieter evidence of actual life. And once you accept that, the world becomes fuller and slightly less certain. A bay may have once been a street. A hill may be a wall fielded by grass for centuries. A line of trees may follow an ancient embankment. A calm stretch of seabed may hold a harbour. A patch of jungle may conceal not just stone but planning. And yet cities, for all their scale, are still only one kind of hidden archive. Built places tell us what people made, organised, worshipped, stored, traded and abandoned. But some of the most intimate records of the past were not buried in avenues or ports at all. They were sealed in tighter places, deeper places, natural places where darkness, mineral crust and still air preserved traces of human presence that no city wall could keep for so long, because sometimes the most revealing things Earth hides are not urban at all, but waiting in caves where whole stretches of human history sat quietly out of sight. There is something about a cave that changes the way people think. Perhaps it is the darkness, or the cool stillness, or the fact that stepping inside feels less like entering a place and more like crossing a boundary. Outside, the world behaves in familiar ways. Wind moves through grass. Birds complain about things that are probably none of our business. Light changes by the minute. Weather is everyone's problem. Inside a cave, all of that begins to fall away. Sound tightens, air settles. Time becomes harder to judge. A few steps in, and even the most sensible person starts feeling that the ground may know things it has not been sharing. That instinct is older than science. Humans have long treated caves as special, useful, unsettling and meaningful all at once. They have been shelters, storage places, shrines, graves, art galleries, traps, hideouts, and emergency refuges. They have also turned out to be some of the most powerful archives of human history ever found. This should not really surprise us. If Earth is good at keeping secrets, caves are among its best filing cabinets. They are protected from sun, wind, and much of the weather that strips the surface clean. They can remain stable for astonishing stretches of time. Sediment builds up slowly, ash falls and stays where it landed, bones remain where scavengers could not reach them, footprints can harden in mud and then be sealed. Pigment on a wall, shielded from rain and daylight, may last for tens of thousands of years if later humans do not come along and decide that their initials deserve equal status with prehistoric art, which, sadly, some people have believed with great enthusiasm and very poor judgment. A cave is not a perfect archive, of course. Water can flood it. Animals can disturb it. Rock can collapse. Later occupants can mix layers, dig pits, light fires, leave trash, or move older material without meaning to. But compared with the open world, caves are unusually good at preserving traces of the brief and fragile creatures who entered them. One of the first things caves preserve is habitation itself. Long before people built permanent towns or cities, many groups used caves and rock shelters as temporary or repeated places of residence. Not because every early human spent life hiding in a dramatic cavern, which is a very persistent image and not especially accurate, but because a good shelter is a good shelter. A rock overhang or cave mouth offers shade, dryness, protection from wind, and in some climates a welcome moderation of temperature. It is not hard to imagine the practical appeal. If you have limited tools, limited carrying capacity, and a perfectly good limestone recess already standing there, like nature's unfinished real estate project, you use it. Fires are lit, food is processed, stone tools are made or repaired, people sleep, talk, argue, recover, perhaps laugh at someone who has once again put the best flint in the wrong place. Then they leave, or they come back seasonally, or another group uses the same shelter centuries later. And because caves keep layers well, those episodes can accumulate into long, deep records of repeated human presence. That layered quality is one of the great gifts and frustrations of cave archaeology. A single site may contain traces from many different times, sometimes separated neatly by sediment, sometimes mixed inconveniently by later disturbance, water, or animals who had no respect at all for our desire for a tidy sequence. Still, when the layers hold, they can preserve whole stretches of prehistory that would otherwise have vanished. Stone tools in one level, hearths in another, bone fragments elsewhere, pollen, charcoal, shell, beads, pigments, broken points, burned seeds, and microscopic residues all settling into a record of presence. The cave does not narrate. It does not hand over a diary. It provides evidence in pieces, and from those pieces archaeologists try to reconstruct who was there, when they came, what they ate, what they made, what climate they were dealing with, and whether they returned often or only briefly. It is patient work, and often less cinematic than popular imagination prefers. There is a great deal of brushing, measuring, sieving, labelling, comparing, and saying things like, "Please do not step there," in tones that suggest stepping there would be socially and scientifically unforgivable. Then there are the bones, which caves have preserved with a stubborn effectiveness that has changed our understanding of humanity again and again. It is difficult to overstate how much of what we know about ancient human relatives has come from cave contexts. Remains of Neanderthals, early modern humans, and other hominin groups have been found in cave deposits because caves protect what the surface usually destroys. Sometimes the finds are dramatic: a skull, a skeleton, a partial burial. More often they are maddeningly fragmentary: a tooth, a finger bone, a jaw fragment. Pieces that look unimpressive until analysis reveals they belong to someone who can alter the human family tree. That is one of the recurring lessons of this subject. The Earth does not always hide its biggest truths in the biggest packages. A small fragment from a cave can do more to reorder human history than a monument ever could. Consider how often caves have forced a rewrite of what it meant to be human in the past. For a long time, people imagined prehistory in rather blunt terms. Simple sequences, simple populations, one kind of human replacing another in a straightforward march toward us, who of course were assumed to be the polished end product of the whole affair. Then cave finds began complicating that comforting picture. Neanderthals turned out not to be the crude caricatures they were once made out to be. Evidence from caves contributed to a very different portrait, one involving tool use, care for the injured, possible symbolic behaviour, adaptation to difficult climates, and a much richer story of interaction with early modern humans than older stereotypes allowed. Later, a cave in Siberia yielded a tiny bone fragment and a few teeth that revealed the existence of an entire, previously unknown group now called Denisovans. Imagine being so well hidden by time and geology that an entire branch of the human story waits in darkness until a finger bone introduces itself to modern science. If Earth has a sense of irony, that would be a good example. Caves do not only preserve bodies and tools, they preserve behaviour in more intimate ways. Hearths tell us about repeated use of fire. Cut marks on bone speak of butchery and diet. Pigments hint at planning and symbolic activity. Spatial patterns show where people sat, worked, slept, discarded waste, or returned repeatedly over generations. In some caves, the floor itself has held footprints, handprints, finger flutings in soft surfaces, and traces so direct they almost bypass interpretation and become encounter. A stone tool is informative. A footprint is personal. It carries weight differently, in every sense. Here was a person, or a child, or several people, moving through wet sediment under low light in a chamber deep enough that they must have entered intentionally. That kind of evidence narrows the emotional distance between present and past in a way few objects can. Suddenly, ancient humans are no longer abstract categories in a chart. They are bodies in motion, navigating uneven ground much as any of us would, probably with a similar and entirely reasonable suspicion that caves contain more things than one can see at first glance. And then, of course, there is cave art, perhaps the most astonishing category of all. It is one thing to find evidence that ancient humans survived, hunted and sheltered. It is another to find that they painted, engraved, and marked underground spaces with extraordinary skill and intention. Deep cave art has a way of undoing modern arrogance very efficiently. People who still carry some lazy idea that the distant past was peopled by dull minds with limited imagination tend to lose that confidence quickly when faced with the sophistication of prehistoric imagery. Animals rendered with motion and shape, hands pressed or stenciled onto walls, abstract signs repeated in meaningful patterns, the strategic use of rock contours to create depth and form. None of this suggests simple minds idly doodling between mammoth sightings. It suggests planning, memory, symbolic thinking, technique, and social meaning we still do not fully understand. What is especially striking is that much of this art was placed well beyond the cave mouth. Not in convenient daylight zones where one might absent-mindedly scratch at a wall while waiting for dinner, but in darker inner spaces requiring deliberate entry. That raises all kinds of questions. Why go that far in? Why mark those chambers? Who was allowed to enter? Was the experience ritual, educational, social, or some combination of all three? Were sounds, shadows, and echo part of the effect? Did certain routes matter? Did some caves hold meanings distinct from ordinary living spaces? We do not know in full, and that uncertainty is part of what gives cave art its power. The preservation is remarkable, but it is still only partial. We have the marks, not the explanations. We see the final result, not the full event of making. Earth kept the images. It did not preserve the spoken language around them. There is something almost unfair about that. A cave can hold pigment on stone for tens of thousands of years, and yet remain perfectly silent about the story being told, the song being sung, or the person who first held a lamp up and decided that this particular wall, this bulge of rock, this turn in the passage, was where an animal should emerge. Perhaps that is why these places feel so charged. They give us undeniable evidence of minds like ours and unlike ours, close enough to recognise, distant enough to remain partly opaque. We're used to history becoming clearer as evidence improves. Caves often do the opposite. The more they reveal, the stranger the humans inside them become, not less human, but more complicated than old narratives allowed. Burial is another reason caves matter so much. Many human groups used caves or cave-like spaces for the dead, whether as formal tombs, repeated burial locations, secondary deposition sites, or places where natural hollows took on ritual meaning. The motivations varied widely across time and culture, but the archaeological consequence is clear. Caves became places where the dead were placed deliberately, sometimes with objects, sometimes after specific treatment, sometimes in ways that indicate care, memory, and repeated visitation. These burials matter not just because they preserve skeletons, though that is obviously important, but because they preserve attitudes. To bury is to do more than dispose. It is to organise loss. It tells us something about kinship, fear, reverence, obligation, or belief. Even when interpretation remains contested, the very act of placement inside a cave suggests that certain natural spaces carried significance beyond shelter, and significance leaves traces in more than bone. Caves sometimes preserve ornaments, pigments, carved objects, and carefully arranged materials that imply symbolic or ceremonial use. Not always grand ritual in the dramatic sense, but pattern, repetition, intentionality. One of the quieter revolutions in prehistoric research has been the growing appreciation that symbolic behaviour is older, broader, and less exclusive than earlier theories often assumed. Cave contexts have been central to that realisation. The use of colour, the treatment of bodies, the marking of walls, the arrangement of objects, and the repeated use of certain chambers all hint that ancient humans were not merely surviving the environment in a grim and practical trance. They were making meaning inside it, which, to be honest, is a very familiar human habit. Give our species enough darkness, uncertainty, and echo, and someone will eventually turn it into a place of story. Of course, caves are not kind to everyone. Many preserved traces are there because the cave was dangerous, difficult, or final. Animals fall in and cannot get out. People enter and do not return. Collapses seal chambers. Floods trap remains where they lay. Predators use caves as dens, dragging bones inward and creating assemblages that later scientists must sort through carefully, unless they wish to mistake ancient hyena dining habits for human domestic life. Caves preserve, yes, but they also accumulate by accident and violence. This is part of why interpretation is so difficult. A cave deposit is rarely a clean diary of one activity. It is more like a long shared storage room used over thousands of years by humans, animals, water, gravity, mineral crust, and geological bad temper. Untangling that record requires extraordinary care. There is also the issue of access, which has shaped what we know. Many caves remain unexplored, underexplored, or explored only in the most basic sense. To know an entrance exists is not to know the full system. Passages may be flooded, blocked, unstable, dangerously narrow, or filled with low oxygen pockets that make curiosity a poor survival strategy. Some caves are sacred or protected, and rightly not treated as public puzzles for enthusiastic intrusion. Others have been looted, damaged, or trampled by earlier visitors who are less interested in preserving context than in taking souvenirs or leaving boot prints in places that had remained undisturbed for ages. Every cave that yields remarkable knowledge also reminds us how easily such archives can be ruined. A footprint preserved for tens of thousands of years can be destroyed in one careless step. A wall blackened by ancient lamps can be damaged by modern breath, heat, mould, and lighting. Earth kept the chapter safe for ages. Humans can misplace the page in an afternoon. Even so, new methods keep opening the record wider. Ancient DNA extracted from cave sediments has been one of the more astonishing developments in recent years. In some cases, genetic traces remain in dirt even where no obvious bone survives. Think about that for a moment. A cave floor, apparently ordinary, can hold enough biological residue to reveal who passed through long after the body itself has vanished. That feels almost unreasonable, as though the planet has started keeping backup copies without informing us. Micromorphology can read tiny changes in sediment structure. Isotopes reveal diet and mobility. Residue analysis identifies what was burned, cooked, or processed. High-precision dating refines timelines that once seemed hopelessly broad. Bit by bit, caves continue to yield information not because they have changed, but because we have improved at asking. Yet for all the scientific progress, there remains something profoundly simple about the appeal of these places. Caves bring us into contact with human scale in deep time. Cities can be impressive, but they are often about systems and institutions. Caves are smaller, more immediate. A handprint, a hearth, a set of footprints, a child's path through mud, a lampstain on a wall. The edge of a sleeping surface, a bead, a tooth, a cluster of bones placed with care. These are not anonymous monuments to administration. They are intimate traces of bodies making their way through darkness, cold, uncertainty, and ordinary life. It is difficult to stand near such evidence and not feel that history has narrowed unexpectedly. Not vanished, but narrowed enough for recognition. Perhaps that is why caves have repeatedly unsettled neat stories about where humanity came from and how it changed. They keep giving us evidence that does not fit the simplest versions. Overlapping populations, unexpected behaviours, earlier art, more complex symbolism, different migration patterns, long periods of repeated use, signs of contact, signs of difference, signs that human history was not a straight line marching confidently toward the present, but a tangled, branching, adaptive, deeply local story written in many environments by more than one kind of human. Caves did not create that complexity, of course. They merely kept enough of it for us to notice, and once you accept that, the world above ground starts feeling thinner again. A hillside may look ordinary while containing chambers that hold hundreds of centuries of human presence. A narrow opening may lead to sediments layered with climate shifts, extinctions, tool traditions, and species interactions that no open campsite could have preserved so well. A cave wall may carry marks older than cities, agriculture, or writing, and still look, at first glance, like just another surface of stone. That is the quiet genius of Earth's secrecy. It does not always hide history in spectacular ways. Sometimes it folds it into darkness and lets patience do the rest. Which leads naturally to another thought. If caves can keep such careful records of human presence, they can also preserve evidence of lives older and stranger than our own. Bones far beyond memory, creatures no person ever saw alive, whole vanished worlds compressed into stone or sealed in protected deposits, waiting until someone notices that what they first took for a rock is in fact a tooth, a vertebra, a skull, or the outline of something the earth tucked away long before humans began asking questions in caves at all. And that is where the story widens again, because once caves teach us to trust the earth as an archive, it becomes easier to understand why so much of life's older history survives in fragments scattered far beyond any shelter. Not all of the planet's memory sits in chambers or under painted ceilings. A great deal of it lies in stone, in exposed cliffs, in dry basins, in mud turned to rock, in bone beds, tar seeps, frozen ground, riverbanks, quarry walls, and slopes where weather has done the rude but useful work of peeling back time. If lost cities remind us that human arrangements can vanish, fossils remind us of something larger and less flattering. Whole worlds vanish too. Not just settlements, not just dynasties, not just languages, but species, ecosystems, and ways of living so complete in their own time that they must have seemed permanent to themselves, if animals thought about permanence at all, which mercifully they probably did not. A giant ground sloth, one suspects, had other priorities. There is a peculiar comfort and discomfort in fossils. Comfort, because they prove that life leaves traces. Discomfort, because they also prove how little is required for almost all of it to disappear. Most creatures that have ever lived on Earth left nothing we will ever find. No skeleton in a museum, no footprint in a slab, no shell in a drawer, no tooth glinting out of sediment, not even a useful smear of chemical evidence to say, yes, something with ambitions and a digestive system was here once. Decay is usually efficient. Bodies are eaten, scattered, dissolved, crushed, recycled, and mixed back into the world with brisk competence. Fossilization is the exception, not the rule. It requires a set of circumstances so selective that survival through deep time almost feels less like preservation and more like a statistical miracle that occasionally happens to something with especially durable teeth. That selectiveness matters because it shapes the entire fossil record. The Earth does not preserve life evenly. Hard parts do better than soft ones. Bones, teeth, shells, and wood under the right conditions can stand a chance. Soft-bodied creatures usually vanish unless buried in extraordinary settings where oxygen is low, disturbance is minimal, and conditions conspire to keep delicate structures from collapsing into soup. Even then, preservation is picky. Entire groups are underrepresented simply because their bodies were not built for posterity. Others appear frequently because they had the practical sense, from our perspective at least, to come equipped with shells, armour or skeletons that mineral-rich water could later help turn into stone. In that sense, the fossil record is not a complete library. It is a heavily damaged, biased collection with missing volumes, warped pages, and certain sections consisting mostly of teeth. Still, what a collection it is. From those scattered remains we have reconstructed worlds no person ever saw. Forests of giant club mosses and horsetails in swampy carboniferous landscapes. Seas full of shelled things, spines, jaws, and stranger designs from older periods when evolution seemed to be trying ideas at a rate that suggests very little adult supervision. Reptiles of improbable scale. Mammals once bigger, stranger, and more regionally varied than the neat parade presented in children's books. Birds with teeth, armoured fish, marine reptiles, saber-toothed predators. Mammoths, mastodons, giant deer, giant wombats, giant beavers, giant short-faced bears, and a surprisingly large number of extinct animals, whose chief message to the future appears to be that evolution occasionally became enthusiastic and then had to calm down again. The important thing is not only that these creatures existed, but that Earth kept enough of them for us to find. Bones are especially powerful in this regard because they sit at the intersection of anatomy and accident. A bone is a useful structure in life and a durable object in death, but only up to a point. Once the animal dies, a great many hazards compete to erase the remains. Scavengers pull apart the carcass, weather cracks the surface, water transports pieces away from one another, soil chemistry dissolves, trampling breaks, roots invade, sediment buries, which may help or harm depending on timing and depth. Then, if burial is followed by the right long-term chemical conditions, minerals may move in and replace or stabilize the original material. What begins as a living skeleton becomes an object in stone. Much later, uplift, erosion, excavation, mining, road cutting, or sheer luck re-exposes the fossil. Every specimen therefore contains two stories at once. First, the biology of the animal when alive. Second, the chain of events that let any part of that life survive at all. That second story is known in science as taphonomy, which sounds a little like something one should not spill on the carpet, but is in fact the study of what happens to organisms between death and discovery. It is one of the great reality checks in paleontology. People like to imagine a dinosaur dying gracefully in a pose convenient for museum display, then lying still for millions of years like a committed actor waiting for the lighting cue. In reality, most bodies have a rougher journey. Parts go missing. Position shifts, sediment compacts, layers distort, bones break and mend under geological pressure, predators chew, rivers sort fragments by size and density. By the time paleontologists find a skeleton, they're often working with an incomplete, rearranged, slightly insulted version of the original animal. Much of the skill lies in reading past those alterations and asking what belongs to the creature and what belongs to the long, untidy process of becoming a fossil. There is something rather impressive about how much can be inferred from partial remains. A tooth can suggest diet. Limb bones speak of movement. Joint structure hints at posture and speed. Microscopic growth lines reveal age or seasonal stress. Bone chemistry can indicate environmental conditions or mobility. Pathologies preserve injury, disease, healed trauma, and the sort of bodily wear that says life was neither sedentary nor especially gentle. Even the bite marks left by one species on another can preserve a brief and impolite interaction across tens of millions of years. The fossil record may be incomplete, but it is not mute. It tells us what bodies were built to do, where they lived, what they suffered, and sometimes how they died. That is a great deal to wring from stone, and one of the reasons fossil discovery continues to feel less like collecting objects and more like interviewing a witness with a very long delay and a tendency to answer only in fragments. Some of the most striking finds are not isolated skeletons but bone beds, places where remains accumulated in unusual numbers. These can form in many ways. Drought concentrates animals at shrinking water sources, floods transport carcasses into low areas, predators drag prey to favoured spots, natural traps capture the unwary, ash falls, mud flows bury. In such sites, the earth preserves not just one animal, but an event, or a repeated pattern of events. A mass death assemblage can tell us about climate stress, migration behaviour, social grouping, predator pressure, or sudden catastrophe. It can also tell us, rather bluntly, that the world has never been especially protective of large herds standing in the wrong place when conditions turn. There is a sombre quality to these sites, but also a scientific richness. One skeleton is informative. Hundreds, sorted carefully through sediment and context, can reconstruct an ecosystem under pressure. Natural traps deserve special mention because they are both grim and useful, a combination Earth employs frequently. Tar seeps, sinkholes, fissures, caves, mud traps, and unstable margins around water bodies can all accumulate remains over time. An animal is lured by water, salt, food, or what appears to be ordinary ground, then becomes stuck or falls in. Predators arrive attracted by distress and join the collection. Sediment, mineral deposition, or sticky hydrocarbons do the rest. What looks at first like a cruel arrangement becomes in deep time an extraordinary archive. Such deposits can preserve entire faunas from particular periods and regions, sometimes in remarkable abundance. They show not only what species were present, but how they interacted, which age groups are common, what injuries recurred, and what environmental pressures shape their lives. In other words, Earth occasionally builds museums the hard way. Then there are the rare deposits of exceptional preservation, those wonderful and almost unreasonable cases where the usual rules relax and soft tissues, feathers, skin impressions, stomach contents, pigments, or delicate structures survive. These sites have transformed our view of past life because they reveal what bones alone cannot. A skeleton gives form. Exceptional preservation gives texture. Suddenly ancient creatures gain coverings, colours, soft anatomy, developmental stages and details of function that bones only hinted at. Entire conversations about behaviour, thermoregulation, locomotion and evolutionary relationships change because one deposit somewhere happened to capture life in more generous detail than usual. It is difficult not to feel grateful to whatever ancient mud, fine ash or oxygen-starved basin performed the service, though perhaps gratitude is not quite the right emotion for a process that also involved a good deal of death. Fossils also remind us how often the Earth's forgotten creatures were not failures, but successes cut short by change. Extinction is sometimes described as though it were a moral verdict, or a sign that a species was somehow poorly designed. In truth, many extinct organisms were well adapted to their worlds. The trouble is that worlds do not hold still. Climate shifts, sea levels move, continents drift, volcanism alters the atmosphere, new predators appear, old food sources vanish, competition changes, diseases spread. Entire ecosystems can be undone by events no one species is equipped to negotiate. The fossil record is full of creatures that worked perfectly well until the conditions around them stopped cooperating. There is a lesson in that, and not a particularly soothing one if you enjoy the thought of stability. The Earth does not guarantee continuity, it permits it for a while. Mass extinctions are the clearest expression of this rule. Layer by layer, the rocks record intervals when large portions of life disappeared in geologically short spans. Not everywhere equally, not always instantly, but decisively enough to redraw the living world. Marine communities collapse, land faunas turn over, dominant groups shrink or vanish, survivors diversify into the empty spaces. We often focus on the famous examples because they come with memorable creatures and a satisfying sense of drama. But the deeper point is broader. The planet has repeatedly reset the terms of life. Entire ways of being common, normal, and widespread have been reduced to bones in stone and a few branch lines that carried on. The Earth forgot them in the practical sense, not erased all evidence but removed them from the living present so thoroughly that only fossils tell us they were ever ordinary. There is a quiet strangeness in that word ordinary. Imagine a time when mammoths were not extraordinary museum pieces or logos on educational posters, but simply part of the fauna. A time when giant ground sloths moved through landscapes without anyone finding that concept remotely unusual. A time when the sea held creatures built to bite, coil, filter, drift, and glide in combinations no living ocean now exactly repeats. Every fossil bed is a corrective to present-day assumptions about what belongs on Earth. We are inclined to think of modern ecosystems as the standard version, and ancient ones as deviations. In reality, today is just one arrangement temporary like all the rest. The forgotten creatures were not bizarre interruptions in the march toward us. They were the world for a while. The emotional force of fossils often comes from that collision between familiarity and difference. A skull can look enough like a mammal skull to feel recognizable, yet belong to something unlike any living mammal. A footprint can look like the track of a bird until you realize the sediment is unimaginably older than birds in any ordinary sense, and the walker belonged to a lineage with its own experiments in movement. A shell can resemble something modern, and still come from a sea whose chemistry, temperature, circulation, and accompanying life were entirely different. Fossils are not simply relics. They are reminders that the categories through which we sort the living world are provisional. Evolution has produced many more forms than the present conveniently displays. This is one reason fossil discovery remains so exciting even now, in an age when people occasionally talk as though science has already tidied up the main story. It has not. New species are described regularly from old collections and new finds. Known groups gain surprising members. Apparent relationships shift as better preserved or more complete material appears. Whole local faunas emerge from regions once poorly sampled. New dating refines old assumptions. Chemical techniques reveal diet, temperature, and growth in more detail. and sometimes a specimen sits in a drawer for decades until someone notices it has been politely refusing its original label the whole time. Earth's forgotten creatures are not all already known. Some are still in the ground, some are on shelves waiting for a better question. There is also a more practical point here. Fossils are not just about satisfying curiosity regarding giant lizards, charming marine invertebrates, or mammals with an unreasonable commitment to tusks. They are records of climate, ecology, adaptation, and environmental change. A fossil assemblage can tell us whether a place was once sea, swamp, forest, floodplain, desert margin, or cold steppe. Plant fossils speak of rainfall and temperature. Microfossils in marine sediments track shifting oceans. Pollen grains, tiny and unexpectedly consequential, preserve long histories of vegetation and climate. The arrangement of bones in a deposit can indicate drought or flood. In other words, fossils do not merely tell us who lived. They tell us what kind of world made that life possible. And because the Earth has changed many times before, those records help us understand both the resilience and vulnerability of ecosystems under pressure. Perhaps that is why people are so drawn to bones. Bones feel direct. A fossil shell is lovely, yes. A leaf impression is informative. But a bone still carries the architecture of a body. It suggests movement, muscle, posture, effort. It hints at breathing, feeding, growing, injury, and death. A femur is not just mineral. It is leverage remembered. A tooth is appetite remembered. A vertebra is motion remembered. Even when mineralized beyond anything recognizable as fresh biological material, the shape remains a testimony to life's engineering. That is why museum skeletons affect people in a way that isolated stones usually do not. One can look at a mounted skeleton and reconstruct the animal in the mind, sometimes in alarming detail. It stood, it turned, it hunted or grazed, it occupied space with intention. Then it was gone for millions of years and returned as evidence. Still, the Earth does not preserve only the grand and toothy. Trace fossils, the marks left by living things rather than their bodies, are among the most revealing records we have. Tracks, burrows, nests, coprolites, tooth marks, and feeding traces can say as much about behaviour as bones say about anatomy. A footprint records movement through a moment. A burrow records habit. A nest records reproduction. Fossil dung, though admittedly less glamorous at first glance, records diet and ecology with admirable frankness. These traces are valuable because they preserve action rather than just structure. They are life in progress, interrupted and saved. And they underline again that the world forgot these creatures only in one sense. It forgot them as living participants. It did not entirely erase the things they did. There is something almost philosophical in that distinction, though not in a needlessly misty way. The Earth is not a sentimental keeper of memory. It does not preserve because something deserves to be remembered. It preserves because chemistry, burial, pressure, and luck occasionally align. Yet the effect, from our side, feels very much like memory. A forgotten creature becomes present again, not alive, not recoverable in full, but legible enough to enter human thought. A child looks at a skeleton, and suddenly the past is crowded again. A researcher splits open a rock and finds a fish, a fern, a trackway, a tooth, and the world expands backward. What had seemed empty, deep time becomes inhabited. That is no small thing. The fossil record gives the planet a past dense with lives rather than merely dates and disasters. And because those lives are distributed through stone, the landscapes holding them begin to change in our eyes. A dry basin is no longer just dry. It may once have held water and herds. A cliff is no longer only a cliff. It is a stack of former worlds waiting for weather to expose them. A mountain range lifts rocks that were once seabed. A desert floor may hide trackways under a crust. A quarry wall becomes a timeline. Even the colours of sediment take on meaning. Red for ancient oxygen-rich conditions, dark for organic, rich, quiet waters, pale for carbonate seas, bands and lenses recording shifts that would have been invisible to any creature living through them day by day. Stone remembers too much, in a way. It keeps more world than the surface can display at once, and once that thought settles in, it becomes easier to see why certain landscapes feel so heavy with withheld information. Not just caves now, but mountains, deserts, cliffs, and great exposures where the ground itself seems overstocked with evidence, as if every layer is trying to tell on a different age at once. And the only reason we're not overwhelmed by it daily is that most rock is merciful enough to keep its mouth shut until weather, erosion, or a well-placed hammer persuades it otherwise. And that in turn brings us out into the open again, to the places where Earth seems least interested in subtlety, and yet somehow still manages to conceal whole histories in plain sight. Mountains, deserts, and exposed stone often look like the honest parts of the planet. No leafy cover, no convenient mud to bury a city whole, no deep cave darkness quietly archiving a lamp stain or a footprint. Just rock, heat, height, wind, distance, and the stern impression that if something important were lying there, surely someone would have noticed by now. This is one of the many ways the Earth encourages overconfidence, because bare landscapes can be among the most deceptive of all. They appear stripped down, but in reality they are overloaded with memory. They do not merely hold traces of the past. They display them in layers, fractures, sediments, uplift, erosion scars, mineral seams, and abandoned channels so densely that the real difficulty is not finding evidence, but learning how to read what is already in front of you. Stone is especially good at this because it does not remember in the human sense. It does not keep stories in sequence with a beginning, middle, and satisfying conclusion. It records pressure, heat, burial, uplift, cracking, intrusion, deposition, and the general bad habits of continents over extremely long periods. If you ask it a simple question, it usually answers with several million years of complications. A cliff face may look like a wall of rock, and be in fact the compressed remains of seas, deltas, deserts, floodplains, volcanic ashfalls, and ancient soils all stacked one above another like drafts of a planet that could never quite stop revising itself. A mountain path may cross stone that formed underwater, then sank, then rose, then folded, then fractured, then was scraped by ice, then walked by shepherds, soldiers, traders, climbers, and people who absolutely should have packed a better lunch. None of that is visible at a glance, yet it is all there. The problem is not that the Earth failed to preserve the record. The problem is that the record is written in a language of processes rather than intentions. Mountains are perhaps the grandest example of this. We tend to think of them as symbols of permanence, which is understandable. They are large, they loom, they have a tremendous gift for making our projects seem temporary and our parking arrangements trivial. But mountains are not monuments to stillness. They are evidence of upheaval. Most of them exist because the crust would not sit quietly, and the deep structure of the Earth continued, over unimaginable stretches of time, to shove, buckle, lift, melt, and rearrange material into forms dramatic enough to produce postcards and very sore carves. A mountain range is not simply a place. It is an argument that the planet once did something violent, and then had the patience to let erosion edit the result for a few million years. When you stand in high country, you're not looking at a finished object. You're looking at the current stage of a long collision between uplift and destruction. That matters for hidden history because uplift exposes what burial once protected. Layers that formed far below the surface can be lifted into view. Marine sediments become cliff faces. Ancient river deposits appear halfway up a slope. Fossils weather out where no sea has existed for ages. Mineral veins formed under heat and pressure are brought close enough to the surface for humans to discover them and, with our usual restraint, dig enthusiastically. A mountain is therefore both concealment and revelation. It keeps secrets by being hard to access, dangerous to cross and constantly unstable in detail, but it also tears open deep time and lets fragments of older worlds spill into the present. The same range that hides a cave system, an ancient route, or a preserved ice patch may also expose rock older than any story humans ever told there. High places preserve human traces in peculiar ways too, not because they are gentle, but because they are selective. Organic material can survive in cold, dry or protected niches long after it would have vanished elsewhere. Objects dropped on high passes, preserved in ice or trapped under rockfall, can sit for centuries before climate shifts or seasonal melt reveal them. Paths worn by generations of movement may remain legible in terrain where later development did not obliterate them. Rock shelters at elevation can preserve brief episodes of seasonal use. Sacred sites, hunting camps, shrines, burials, and travel corridors all leave marks, though often faint ones. The difficulty is that mountains disperse attention. A valley draws settlement, a summit draws admiration. Everything in between can remain oddly underread for long periods, despite the fact that people have crossed, used, and interpreted mountainous terrain for as long as there have been people with knees and questionable plans. There is also the simple matter of access, which mountains weaponize beautifully. A feature can be known in theory and still remain effectively hidden, because reaching it is exhausting, dangerous, seasonal, or all three. A cave mouth in a cliff, a fossil bed in an unstable exposure, a high-altitude lake preserving ancient sediments, a ritual site on a ridge, a sheltered deposit beneath talus, all may sit in the open while remaining understudied for entirely practical reasons. The map shows them. The mountain keeps them. Researchers are not generally deterred by difficulty, but difficulty does slow everything down. Equipment must be carried. Weather windows are short, slopes collapse, snow lingers, crevasses open. Altitude makes ordinary thinking feel slightly borrowed. One begins the day with scientific ambition and ends it grateful to have boiled water without incident. In such places, the Earth does not need to hide evidence behind mystery. It can simply leave it uphill. Mountains also remember climate in a way that makes them especially rich and occasionally alarming archives. Glacial landforms, moraines, polished rock, erratics, lake sediments, and preserved ice all tell us that the cold has advanced and retreated many times, reshaping valleys and rerouting water. A mountain landscape that looks eternal may in fact be the temporary result of recent deglaciation. Its smooth basins, sharp ridges, and hanging valleys, all cut or exaggerated by ice, no human settlement could have negotiated comfortably. When those glaciers retreat, they reveal and destabilize at the same time. Ancient wood, tools, pathways, hunting remains, and even human bodies can emerge from melting ice patches, released into a warmer world that was not the one they entered. There is something deeply strange about that. The mountain does not simply preserve. It times its revelations according to changes in climate that may themselves carry warnings. What comes out of ice is never only an object. It is also a message about conditions then and now. Deserts, by contrast, preserve through exposure, dryness, and the refusal of life to interfere too much, at least not in the usual lush and overgrown way. They can feel empty because the visual field is simplified. Long horizons, bare rock, sand, gravel plains, dry channels, heat shimmer, a horizon that politely declines to come any closer. But emptiness is not the same as absence. In deserts, things survive that would rot quickly elsewhere. Wood, textiles, leather, basketry, food remains, dung, trackways, even writing can persist under the right conditions with unnerving clarity. At the same time, deserts hide through movement. Sand migrates. Flash floods cut through surfaces and cover others. Salt crystals disrupt. Wind abrades details from exposed stone while burying nearby features under new deposits. This means that a desert can preserve beautifully and conceal ruthlessly in the same gesture. A grave may survive intact under dry cover for ages. A settlement beside it may be half erased by drifting dune faces. A caravan route may be visible from the air and invisible from the ground. A rock panel may remain legible for millennia because it's sat in the correct angle of shade. Another, just meters away, may have weathered into near silence. The psychological effect of desert landscapes is part of the problem. People often assume that because they can see far, they can understand far. But in arid regions, scale is deceptive, distance is deceptive, and significance is frequently low to the ground. A shallow depression may be an ancient water source. A line of stones may be a field boundary, a trap, a route marker, or nothing at all until studied in context. A scatter of pottery can indicate a seasonal encampment or a node in a much larger network. Dry lake beds can hold prints, tools, and environmental records. Ancient river channels, invisible until one learns how to read aerial imagery or subtle topography, can explain the placement of whole settlement systems. The desert does not keep its secrets by clutter. It keeps them by reducing the landscape just enough that the unwary observer mistakes simplicity for transparency. Stone in these regions can be particularly talkative if you know where to look. Rock art panels preserve images of animals, people, weapons, herding, hunting, ritual, movement, and sometimes environments that no longer exist there. A dry cliff may carry records of a greener world, one in which cattle grazed, wild fauna were abundant, and water persisted more reliably than it does now. That means the stone is not only preserving human expression, it is preserving environmental contradiction. It shows that the landscape itself has changed profoundly. In this way, a desert wall can become a record not just of people living in the place, but of the place becoming another place entirely over time. That is one of Earth's more disorienting habits. It lets environments overwrite one another so thoroughly that only a picture carved into rock or pollen in a buried layer reminds us that today's harsh openness was not always the local personality. And then there are the great rock formations, cliffs, canyons, escarpments, plateaus, and exposed sedimentary sequences that seem at first like the least subtle features imaginable. Surely nothing could be hidden in a canyon wall the size of a civic argument. Yet these are often where the deepest histories sit most plainly and most unread. Layer after layer records shifts in sea level, drought, flood, volcanic ash, soil formation, life, death, erosion, and burial. A trained geologist can read broad environmental changes from colour, grain size, sedimentary structures, fossil content and chemistry. To the untrained eye it may look like pleasing stripes. This is not a failure of observation so much as a reminder that visibility is not comprehension. The Earth can show you everything and still remain obscure if you do not know what the patterns mean. Canyons are especially rude in this respect. They make the planet's age visible in cross-section, almost indecently so, while also emphasizing how little of that time humans occupy. Walk down through a deep canyon, and you are, in a literal sense, descending through pages. Younger layers above, older below, each representing intervals far beyond ordinary intuition. Somewhere in those layers may be footprints, burrows, bones, ash beds, fossil soils, ancient river gravels, or marine sediments packed with microscopic life. Somewhere a long dry stream once wandered, somewhere dunes migrated, somewhere a swamp sat under humid air. Now the entire sequence stands open in dry light, while tourists take photographs and wonder whether they have time for lunch before the drive back. This is one of the Earth's best jokes. It puts 1 billion years of environmental change in a place with a gift shop. Mountains and deserts also keep memories of water, which may be the strangest thing about them. One of the first shocks in learning to read landscapes is realizing how many dry, high or barren places are built from old oceans, vanished lakes, river systems, and glacial histories. Seashells in mountain rock, ripple marks in stone far from any shore, fish in shale on a plateau, ancient beaches stranded inland. river terraces perched above current channels like abandoned staircases, deserts crisscrossed by paleo drainage, their former wetness legible only from certain angles or through certain methods. The land remembers water long after water has changed its mind. That matters because water is often the organising force behind both life and concealment. Where it flowed, things lived. Where it stagnated, things were buried. Where it retreated, it left evidence behind in ways sometimes generous and sometimes maddeningly partial. It is tempting to think that a place with exposed rock must have given up most of its secrets already. After all, erosion has done the excavation. The cliff face is open. The slope is bare. The wash has cut through old deposits. But erosion is not a librarian. It reveals by destroying, often just enough to hint at what remains deeper in or farther upslope. A single bone weathering out of a hillside may indicate a rich deposit still embedded behind it. A few artifacts in an arroyo can signal a site actively washing away faster than it can be recorded. A trail of fossil fragments below a cliff may mark a horizon of preservation still locked in the rock above. In that sense, open landscapes are often emergency archives. The memory is visible because the container is breaking. Researchers must read quickly before the next season removes more context. Earth remembers too much, yes, but it does not always remember it safely. There is also a quieter human history written into stone landscapes, especially those that seem forbidding to outsiders and therefore are often assumed to have been marginal to human life. Mountain passes, desert wells, rock shelters, quarry faces, petroglyph sites, mining districts, pilgrimage routes, seasonal camps, and lookout points all testify that people have long known how to use and interpret hard country. The modern habit of treating such landscapes as empty or peripheral often says more about modern habits than ancient ones. Communities move through these environments with knowledge of water, shelter, hazards, routes, resources, and timing so specific that to lose it would be to make the entire place seem impossible. That too is part of what stone remembers, though it does so unevenly. A carved trail marker, a scatter of slag, a quarry scar, a prayer niche, a wall line against wind, a high path worn into slope, these are all signs that difficult land was never simply blank. The rocks also remember human extraction, which is one of the more complicated kinds of memory. Mines, quarries, tunnels, spoil heaps, cut faces, abandoned adits, and tool marks all preserve episodes when people went into the land not merely to cross it or live near it, but to take from it. Metals, salt, pigments, flint, building stone, fuel. Entire histories of industry and labour sit in mountain flanks and desert margins, sometimes spectacularly visible, sometimes half collapsed and easy to miss, unless you know the pattern of a worked face from a natural break. These places can hold not only material evidence of technology, but records of exposure, danger, organisation, trade, and bodily strain. The Earth gave up something there, and humans left their own layer of memory in return, often at considerable cost to lungs, limbs, and life expectancy. Perhaps what is most unsettling about all of this is the scale mismatch. Humans tend to remember in generations and landmarks. Stone remembers in regimes. A village recalls the winter of deep snow, the drought, the bad harvest, the year the road washed out, the season the glacier looked strange. The old mine collapse people still mention softly. The mountain holds all of that, but behind it are older winters, older droughts, older washouts, older collapses, older ice advances, older forests, older deserts, older seas. The local memory and the geological memory overlap only briefly. This is not cause for despair, only for perspective. The land is not forgetful. It is simply storing far more than our stories can conveniently carry. And once you begin to see mountains, deserts, and stone this way, they stop feeling like the exposed skeleton of the earth and start feeling more like an overfull archive with the drawers left partly open. Every ridge, canyon wall, dry basin, and weathered outcrop carries more information than any single observer can take in. Some of it concerns vanished creatures, some concerns lost climates, some concerns the roots and rituals of people who moved through country we now call empty. Some concerns dangers that repeat on intervals too long for folklore to handle neatly. It is a tremendous quantity of memory, much of it visible, much of it still unread, and some of it so deep below the surface that even these dramatic landscapes only hint at it. Because for all the stories stone can tell once uplift and erosion have done their work, there is still another level of secrecy below the cliffs, below the basins, below the deepest roots people ever walked, in the parts of the planet that no city, cave, fossil bed, mountain or desert fully exposes, the deeper earth that remains mostly inferred, seldom reached, and perhaps hiding the largest and strangest things of all. If mountains and deserts give us the feeling that the earth has opened a few drawers and left their contents half visible, then the deep earth is the part of the house that remains locked, bolted, and generally unwilling to entertain visitors. We speak about it constantly, which is not the same as reaching it. We have diagrams, models, seismic maps, laboratory experiments, mineral physics, magnetic measurements, and enough equations to make a perfectly cheerful person stare into the middle distance. We know a great deal, more than people did even a few decades ago, and yet there is still something quietly astonishing about the basic truth of the matter. Humans live on the surface of the planet whose interior we have never truly entered in any direct and meaningful sense. We scratch the crust, sample what rises upward, measure what passes through, and infer the rest with increasing skill. But the deep earth itself remains mostly a place of indirect knowledge. It is one of the largest hidden realms available to us, not because it is far away in space, but because it begins right under our feet and becomes unreachable almost immediately. That is one of the more humbling facts in science. It is easy to imagine that modern technology has made the whole planet available to inspection, that with enough machinery, patience and funding, we can simply go and look at whatever we wish. And in some directions, that confidence is justified. We can cross oceans, orbit overhead, scan jungles, drill ice, send submersibles into great depths, and build detectors in caves to listen for particles that would prefer very much not to be noticed. But downward is another matter. Downward is hot, pressurized, mechanically hostile, and arranged in layers that become more difficult with almost impolite speed. The crust beneath continents is thick enough to make our ambitions look slightly silly. The mantle below that is vast. Beneath the mantle lies the core, divided between a liquid outer region and a solid inner one, both inaccessible except through the clues they leak into the behaviour of the whole planet. Earth, in other words, is not only hiding things on the surface, it is hiding most of itself underneath. The oddity of that becomes clearer when you consider how thin our lived world actually is. We speak of living on Earth as though we inhabit the thing in full, when in practice we occupy a skin. The crust is the outer shell, and even that is not something we have penetrated very deeply compared with its total thickness. Under oceans it is thinner, under continents thicker, but in either case our deepest boreholes remain tiny insults against a much larger structure. The famous super deep drill projects, remarkable feats of engineering though they were, reached only a small fraction of the way through the crust. Not the mantle, not some glowing underworld of dramatic revelation, just deeper crust. And even that required immense effort, specialized equipment, constant adaptation, and a willingness to confront the basic reality that the deeper you go, the less the Earth cares about your plans. Temperature is one reason, pressure is another. Rock at depth does not behave like the dry, manageable stone in a museum sample or a decorative wall. Under enough heat and pressure, it deforms, creeps, fractures differently, carries fluids, and responds in ways that make direct access much more difficult than the simple act of digging down suggests. The deeper one goes, the less useful ordinary intuition becomes. At shallow depth, drilling is a practical matter of engineering, geology, fluids, stability, and money, which is already enough to keep many people busy for entire careers. At greater depth, the conditions become so extreme that tools fail, drill bits wear, boreholes distort, temperatures threaten equipment, and the rock itself becomes less cooperative in every possible sense. One begins with a mental image of descending nobly into the earth, and ends with a much more realistic appreciation for thermodynamics and broken machinery. And yet, despite never truly reaching the deep earth, we know it is there, and know a surprising amount about how it is arranged. This is one of the triumphs of indirect science. Earthquakes, unpleasant as they are for everyone involved, have also served as one of our greatest sources of information about the planet's interior. When an earthquake occurs, seismic waves travel through the Earth in different ways depending on the material they pass through. Some waves move through solids and liquids, others only through solids. Their speed changes, they bend, they reflect, they disappear into shadow zones where detectors farther away do not receive them in the expected way. By measuring those patterns across the globe, scientists learned that the interior is layered, that the mantle behaves differently from the crust, that the outer core is liquid, and that the inner core is solid. It is a deeply elegant solution to a difficult problem. Since we cannot go there, we listen to the planet ring when it cracks. There is something almost intimate about that, though perhaps intimate is not the word most people use when discussing seismic wave propagation. Still, the principle is striking. The Earth tells on itself under stress. A rupture in one place sends information through regions no human eye will ever see directly, and instruments thousands of kilometers away catch the message. In that sense, the deep Earth is not truly silent. It is constantly revealing its structure through motion, magnetism, heat flow, volcanic activity, and the behavior of the surface above it. The catch is that every clue has to be interpreted. We're not strolling through the mantle with a notebook. We're reconstructing the deep interior from signals, experiments, and fragments brought upward by geological processes, which is rather like trying to describe the layout of a locked building from the vibration of footsteps, the warmth leaking through the walls, and the occasional object thrown from a window. Volcanoes play an important part in this story too. They do not, of course, provide a direct elevator ride to the deep Earth, which is just as well, because the safety briefing for such a trip would be unsettling. But they do bring material upward from depths humans cannot reach. Magmas form under particular pressure and temperature conditions, interact with surrounding rock, rise, stall, differentiate, erupt, and sometimes carry with them fragments of the deeper crust or mantle. These fragments, called xenoliths, are among the few actual pieces of deeper Earth we can hold in our hands without becoming geological ourselves. They are valuable because they offer samples from otherwise inaccessible regions, not complete, not perfectly representative in every case, but real. A volcanic rock may therefore contain within it small clues to conditions far below the eruption site, like a courier bag packed in a hurry by a planet that was not especially concerned with labelling. Diamonds too deserve their moment here, not for their role in jewellery marketing, which has already had quite enough moment, but for their scientific usefulness. Some diamonds form at great depth under high pressures, and inclusions trapped inside them can preserve tiny samples of minerals from the mantle. In a sense, they are capsules sealed under conditions no laboratory can casually reproduce, carrying information upward through rare and violent transport. That is a wonderfully inconvenient way for a planet to provide data, but we work with what we have. A glittering stone in a ring and a mantle inclusion in a research paper are not, to be fair, usually introduced in the same tone, yet both remind us that the deep Earth occasionally allows itself to be sampled only in fragments, under very specific circumstances, and often after being blown upward in a way nobody involved would describe as gentle. Still, Even with seismic data, volcanic samples and high-pressure laboratory experiments, the deeper Earth remains a place we model more than we observe. Take the mantle, for example. It makes up most of the planet's volume, yet when people picture the inside of the Earth, they often imagine a vast ocean of molten rock sloshing about beneath the crust like a pot left unwisely on the stove. The truth is more complicated and, in its own way, more interesting. Much of the mantle is solid, but not rigid in the everyday sense. Over long timescales and under immense pressure and heat, it flows. Very slowly, certainly, which is generally the preferred speed for continental rearrangement, but flows nonetheless. Convection in the mantle helps drive plate tectonics, subduction, rifting, volcanism, and the long restless behaviour of the surface. That means the ground beneath our feet is not sitting on a quiet foundation. It is part of a moving system linked to a deep interior we cannot directly inspect. This is one reason the deep Earth feels so strange. It is hidden yet active, remote yet constantly shaping the visible world. Continents drift because of it. Mountains rise because of it. Ocean basins open and close because of it. Volcanoes erupt because of it. Earthquakes redistribute stress through systems tied to it. The magnetic field that shields the planet from charged particles depends on motion in the liquid outer core. In a practical sense, the deep Earth is not merely beneath us, it is involved in almost everything. And yet, if you asked a person standing on a calm street what they can directly perceive of the mantle or core at that moment, the honest answer would be nothing at all. We live above a hidden engine and mostly notice it only when it becomes rude. There are also regions within the Earth that sound almost fictional, until you remember that geophysicists are usually not in the business of inventing dramatic scenery for fun. The transition zone within the mantle, for example, is an interval where minerals change structure under pressure. This is not the sort of phrase that usually makes it into casual conversation. More's the pity. But it matters because the way minerals behave at depth affects how water is stored, how waves move, and how the interior circulates. And yes, water, or more accurately hydrogen bound into minerals, is part of this hidden story too. Deep inside the Earth, certain minerals can hold water within their crystal structures. Not underground lakes in the ordinary sense, not an ocean with fish and regrettable property values, but chemically bound water in quantities that may be significant on a planetary scale. Which is an excellent example of how the Earth likes to hide things in ways that frustrate literal-minded imaginations. Ask for hidden water, and the planet gives you mineral physics. Even deeper still, there are structures near the boundary between the mantle and the core that scientists infer from seismic behaviour, and that remain among the most mysterious features inside the planet. Regions where waves slow oddly, large, deep provinces with distinct properties, possible remnants of ancient processes from early in Earth's history, dense material pooled or preserved in ways not fully settled by present models. These are the sort of discoveries that make the deep Earth seem less like a tidy layered onion and more like a place with its own internal geography, one that we have only begun to sketch. It is not enough to say crust, mantle, core and be done with it. The deeper we study, the more variation appears. Boundaries turn out not always to be simple lines. Layers contain structures, transitions, anomalies, and histories. The hidden interior becomes more detailed precisely because we cannot go there, and must instead become more clever about inference. There is a deeply human tension in that. We are a species that prefers to trust what it can see, touch, and point at. The deep Earth denies us that comfort. It requires confidence in methods rather than direct experience. It asks us to accept that a thing can be well evidenced even if no one has stood beside it. This is not unusual in science, of course, but it remains psychologically odd. People are quite comfortable believing in distant galaxies revealed through instruments and equations, but become slightly restless when told that large portions of the planet itself are known only through indirect signs. Perhaps that is because space has always been presented to us as remote, while the ground feels personal. The idea that the deepest part of our own world is less accessible than the moon feels like a mildly embarrassing administrative oversight. There have been serious efforts to push downward farther, and they deserve admiration. Deep drilling projects have taught us invaluable things about the crust, heat, fluids, rock behaviour, ancient geology, and the practical limits of engineering. But they also taught humility. The Earth grows less accommodating with depth. Temperatures climb faster than some planners hoped. Rock properties change. Equipment reaches limits. The idea of drilling to the mantle under continental crust begins to look less like an engineering challenge and more like a prolonged negotiation with physics in which physics already has a lawyer. Under oceans, the crust is thinner, and scientific drilling has made impressive progress there too. But even so, truly reaching and sampling the mantle directly remains a major challenge. Every attempt reminds us that down is not a direction humans have mastered in any comprehensive way. This difficulty has given the deep Earth a peculiar status in the imagination. It is scientifically real, richly studied, and central to everything from tectonics to magnetism. Yet it still carries a faint aura of underworld thinking, as though somewhere inside all our data remains the older sense that below the surface lies a realm both foundational and inaccessible. Ancient cultures filled the underground with gods, dead ancestors, punishments, treasures, entrances to other worlds, and various entities best left unnamed after dark. Modern science has replaced that mythology with phase transitions, convection cells, iron alloys, and rheology, which is undeniably less dramatic in a storytelling sense, but the emotional structure is not entirely gone. We still feel that beneath the ordinary ground lies something larger than experience, something hidden, powerful, and mostly beyond reach. We have simply learned to speak of it with better instruments and fewer torches. It is also worth saying that hidden does not mean empty. The deep subsurface, even in places far shallower than the mantle but still beyond ordinary experience, contains surprising forms of life. Microbial communities exist underground in rock pores, fractures, sediments, and aquifers, sometimes drawing energy from chemical processes rather than sunlight. This is not the same as saying the deep Earth is teeming with monsters, which will disappoint a certain type of listener, but probably comfort everyone else. It does mean, however, that the boundary between life and deep geology is more entangled than surface impressions suggest. Beneath the visible biosphere lies another, quieter one, sparse in places, active in others, and important to our understanding of what counts as habitable. That realization has consequences not only for Earth science, but for how we think about life on other worlds. The hidden interior of our own planet has expanded the imaginable, and yet even the deepest biosphere we know remains shallow compared with the full scale of the Earth. Below it, the realm becomes increasingly one of minerals, heat, phase change, and physical conditions that no multicellular creature would describe as inviting. The core, especially, remains gloriously inaccessible. The outer core is liquid metal, mostly iron with lighter elements mixed in, moving in ways that generate the magnetic field. The inner core is solid, despite being hotter than many people would find socially acceptable, because the pressure is so immense that it remains crystalline. That fact alone is enough to make the Earth feel slightly surreal. At the centre of the planet lies a solid metal sphere, surrounded by liquid metal, under pressures and temperatures beyond direct encounter, shaping a magnetic shield that allows life on the surface to continue in relative comfort. And we know this without ever having been there, because the planet betrays its structure through physics whether it means to or not. What is perhaps most impressive is how often the deep Earth turns out to be less simple than our diagrams promised. The core may rotate at slightly different rates relative to the mantle over certain timescales. The mantle may contain long-lived structures from ancient tectonic events. Subducted slabs of crust sink deep into the mantle, carrying surface material downward in one of the great recycling systems of the planet. Heat moves upward, material circulates, water is dragged down and later returned through volcanism. elements partition between regions. The planet is not a static layered cake waiting to be sliced more carefully. It is an active, evolving interior system linked to surface oceans, atmosphere, crust, and life over billions of years. Hidden, yes. Dormant, no. Perhaps that is what makes the deep earth such an effective keeper of secrets. It is not merely inaccessible, it is inaccessible while also being indispensable. We cannot walk into it, but it governs the broad behaviour of the world we can walk on. We infer it from earthquakes, volcanoes, magnetic fields, mineral experiments, gravity, heat flow, and geochemistry, each method giving a partial view. No single approach is enough. Only by combining them do we approach a portrait. Even then, the portrait keeps changing. New data refine old boundaries. New models compete. New anomalies appear where simple stories once stood. The hidden interior is not waiting passively to be completed. It keeps complicating itself as our understanding improves. There is a calm kind of wonder in that. Not the loud wonder of sudden spectacle, but the steady wonder of realizing that the ground below the road, below the basement, below the aquifer, below the deepest mine and the deepest borehole, continues into a world we mostly know by listening. A world of flowing solid rock, metallic currents, trapped water in minerals, subducted crust, rising plumes, enormous pressures, and boundaries that are only boundaries in the limited sense that anything remains stable at such depths. The Earth does not reveal this world directly, because direct access is not really on offer. Instead, it offers clues, carried upward in magma, encoded in waves, hidden in diamonds, written in heat and motion. And once you begin to accept that, another thought follows quite naturally. If the deep earth can store water in stone, recycle surface materials into the mantle, preserve ancient structures in inaccessible layers, and carry the remnants of vanished worlds downward into regions we cannot directly see, then the line between buried surface history and hidden planetary history starts to blur a little. Lost coastlines, drowned valleys, subducted seafloors, vanished basins, ancient impacts, and whole environmental worlds may not just be beneath the land in some simple archaeological sense, but folded into the longer, stranger story of a planet that keeps swallowing, storing, and reshaping its own past far below where we can reach, which is where the next set of hidden things begins to feel even larger than cities, caves, or bones. When most people hear the phrase hidden ocean, the mind usually jumps to something wonderfully impractical. A vast underground sea with black water, impossible silence, and perhaps a few pale fish looking mildly offended by the intrusion. The Earth, being Earth, offers something stranger and less cinematic. Some of its hidden water is not sloshing around in giant caverns at all, but locked inside minerals deep in the mantle, bound into crystal structures under pressures and temperatures no human body could survive, and no ordinary journey could ever reach. That is one of the more reliable habits of this planet. Whenever we imagine a hidden thing in the simplest possible form, the real version turns out to be more complicated, more interesting, and slightly less convenient for tourism. Still, the basic idea remains astonishing. Water, not just on the surface in oceans, rivers, clouds, and ice, but carried downward into the earth and stored in places we cannot directly see, as if the planet has been tucking parts of its own surface history into deeper pockets for far longer than we understood. That hidden water matters because it changes how we picture the planet. It reminds us that Earth is not neatly divided into surface and interior, one wet and familiar, the other dry and abstract. The two are in conversation. Oceanic crust is pulled downward at subduction zones, carrying water-rich minerals with it. Heat and pressure alter them. Some water returns through volcanism. Some may be stored deeper for long periods. The process is slow, enormous, and easy to ignore if one is busy making lunch or missing a train, but it is one of the great circulations of the planet. The Earth is not simply wearing an ocean like a coat. It is cycling water through its own body. Even the phrase hidden ocean becomes a little slippery here, because what is hidden is not one tidy lake below the crust, but a deep distributed system of storage and release that links the sea, the mantle, and the long history of tectonic motion, which frankly is far more impressive than a subterranean beach and considerably less relaxing. There are also hidden waters close to the surface, though no less strange. Beneath ice sheets lie subglacial lakes, isolated from sunlight for immense spans of time, sealed under kilometres of ice, preserved in darkness and pressure while climates shifted above them. Beneath deserts, fossil aquifers hold water that fell as rain in much greener ages. Beneath limestone landscapes, groundwater moves through cave systems no map has fully tamed. Under the sea floor, fluids circulate through sediments and fractures in ways that influence chemistry, heat, and life. So even before we get to buried worlds and ancient catastrophes, the simple question of where water is becomes more layered than it first appears. Water hides, water moves, water is stored in places that once seemed impossible or irrelevant, and wherever hidden water exists, it carries with it the possibility that a former world is somehow still present, whether as climate memory, chemical archive, or the last surviving trace of a landscape that looked nothing like the one above it now. That brings us to buried worlds, which are among the most humbling things the Earth keeps, because some of them are not metaphorical, they are literal landscapes, once dry, once walked, once full of grass, forest, marsh, game, camps, roots, settlements, fires and weather, now drowned beneath continental shelves or sealed beneath sediments. During the Great Ice Ages, when more water was locked up in ice, sea level was lower. Vast stretches of land that now lie underwater were then exposed. Coasts sat farther out. River valleys extended across what is now seabed. People and animals moved over ground that has since vanished below rising seas. To look at a modern coastline is therefore to see only the most recent version of a boundary that has shifted many times. Offshore, beneath layers of sand, mud, shell and marine growth, there may be old shorelines, drowned forests, ancient channels, and traces of human life from periods when the sea had not yet reclaimed them. This is one of the quieter reasons the ocean remains such a frustrating archive. It does not merely hide shipwrecks and dramatic stone ruins, it hides entire former worlds of ordinary use, campsites, hunting grounds, wetlands, pathways, estuaries, fisheries, and small settlements that would have been central to human survival when they were dry land are now submerged, eroded, buried, or chemically altered beneath the sea. And because underwater archaeology is demanding, expensive, and technically awkward in ways that make even cheerful experts sound slightly tired, much of that record remains poorly known. So when we speak of early human prehistory, especially near coastlines, we are often speaking with an incomplete archive, because some of the most attractive and densely used landscapes for ancient people now lie underwater, concealed not by mystery, but by sea level change and the practical limits of marine research. There is something deeply unsettling about that, in a calm and geological sort of way. It means that some of the missing pieces in our story may not be on land at all. They may be offshore, under sediment, in places where currents, low visibility, shifting seabeds, and long periods of inundation have made preservation uncertain and discovery slow. Imagine an estuary rich in birds, fish, shellfish, fresh water, reeds, and game. Imagine people returning to it seasonally or living there for generations. Then imagine the sea creeping landward century by century, enough that no single generation experiences it as the end of the world, but enough that over time the familiar ground disappears, the channels change, the camps move, and what was once central becomes inaccessible. Later memory may preserve the movement, perhaps as story, perhaps as sacred geography, perhaps not at all. The world itself remains, but lower, darker, colder, and harder to study. There are buried worlds on land as well, of course. Entire surfaces can be covered by volcanic ash, flood deposits, landslides, loess, dune fields, lava flows, and glacial sediments. An ancient forest can be flattened, buried, mineralized, and preserved as a ghostly layer of roots and trunks under younger rock. A river plain can vanish beneath repeated flooding until its former channels survive only as stains, textures, or subtle depressions. A peat bog can swallow old ground. A dune sea can migrate over roads, fields, graves, and houses until the landscape appears timelessly barren. In every case, the younger surface creates the illusion that this is simply how the place has always been, when in truth the visible world is only the last draft. Under it may be another climate, another ecosystem, another human use of the land, another arrangement of water and life entirely. Ancient catastrophes are one of the main reasons those buried worlds exist. Catastrophe, in geological terms, does not always mean a single apocalyptic afternoon, though sometimes it does. More often, it means rapid change relative to the ordinary pace of landscapes. A volcanic eruption blankets a region in ash. An impact throws debris around the planet. A glacial lake bursts and releases a flood on a scale almost impossible to imagine from modern rivers. A slope fails. A coastline is struck by tsunami. A basin dries. A fault ruptures and alters drainage. A pulse of warming or cooling shifts ecosystems faster than some species or societies can adapt. The Earth records these events with a blunt honesty that written history rarely matches. Ash layers, tsunami deposits, impact spherules, flood gravels, charcoal horizons, abrupt pollen changes, extinction patterns, and disturbed sediments all remain as testimony that the planet's past was not a gentle, uninterrupted procession of ordinary seasons. It lurched. Impacts are perhaps the most dramatic example because they feel almost unfair. For most of Earth's history, things fell from the sky with more consequence than modern life encourages us to consider over breakfast. When a large asteroid or comet strikes a planet, it does not simply make a hole. It excavates, melts, vaporizes, compresses, shocks, ignites, throws debris, triggers waves, and alters atmosphere and climate depending on scale and circumstance. The crater itself may later erode, fill, deform, or sink below younger sediments, leaving the event hidden until geophysics, shocked minerals, geochemistry, and persistent scientific stubbornness reveal what happened. Some of the greatest catastrophes in Earth's history are therefore not visible as obvious scars to the casual eye. They are buried, modified, and half erased, their reality reconstructed from clues scattered across rock layers, microscopic particles, and global signals. It is a little unnerving to realise that the planet has been struck hard enough to change the course of life, and then gone on to partly hide the evidence. Volcanism is no less important, though it works on different moods and timescales. A single eruption can bury towns, fields, forests, and entire surfaces under ash and pumice. Repeated eruptions can build landscapes while also sealing older ones. Lava flows can trap topography beneath them like a hardening memory. Massive volcanic provinces, formed by prolonged outpourings of basalt, can alter atmospheric chemistry and climate on scales large enough to reshape ecosystems globally. Yet later observers may stand on the resulting plateau or volcanic plain and see only scenery. Beneath the basalt, beneath the tuff, beneath the ignimbrate, lie older soils, drainage systems, plant remains, tracks, and perhaps human traces if the timing is recent enough. Catastrophe does not always erase the older world completely. Sometimes it preserves it by covering it fast, which is a very Earth-like form of rough kindness. Floods deserve more respect than they usually get in popular imagination. Modern rivers can be destructive enough, but some ancient floods were on scales that make even severe modern examples seem almost modest. When glacial ice dams fail or immense lakes drain suddenly, the resulting outburst can carve channels, move boulders the size of houses, strip landscapes, and leave behind giant ripple marks visible from the air. Such floods reorganize regions, they create new topographies, they remove the soil and vegetation that once covered older surfaces and deposit new sediments over others. For a long time, some of these landscapes puzzled geologists precisely because the evidence was too large. The channels, bars, scoured basins, and transport patterns looked exaggerated beyond ordinary experience. Only once the idea of truly catastrophic meltwater release was taken seriously did the terrain begin to make sense. The land had remembered. Human expectation had simply been too small. Tsunamis operate with a different kind of violence, one tied to coasts and lowlands, where people often live in large numbers. Their deposits can be subtle or spectacular depending on local conditions, but when preserved they record a moment when the sea moved inland with unusual force, carrying sand, shells, marine microfossils, debris, and destruction into places that are not normally marine at all. In some regions, repeated tsunami layers reveal a longer hazard history than written records alone would suggest. That matters because catastrophe is not just about the past in a museum sense. Earth's hidden records often turn out to be warnings. A buried sand sheet inland from the coast is not only an interesting sedimentary puzzle, it may be evidence that the shoreline has been crossed before by waves large enough to redraw the map of safety. The same is true for fault scarps, lahar deposits, old landslides, and volcanic ash layers. The planet keeps receipts. Climate shifts can be catastrophic too, even when they unfold over generations rather than hours. Lakes shrink, grasslands turn to desert, cold expands. Wet periods return where dryness had long ruled. Forest boundaries move, species follow, adapt, or fail. Human societies shift routes, diets, economies, and settlement patterns accordingly. In the geological record, these changes may be visible in pollen, dust, lake sediments, speleothems, isotopes, and faunal turnover. To the people living through them, they would have been experienced not as elegant graphs but as failed harvests, altered migration paths, disappearing water, unfamiliar storms, or seasons that no longer behaved properly. A buried world, then, is not always one snapped out of existence by a single event. Sometimes it is a world rendered unworkable by a climate drifting across a threshold, after which the land fills with sand, salt, forest, flood, or silence. There is a reason this part of Earth's history can feel emotionally heavier than fossils alone. Fossils tell us life changed. Buried worlds and catastrophes tell us conditions changed. They show us that landscapes we take for granted are temporary arrangements, dependent on balances that have shifted before and can shift again. A dry basin may once have been a lake. A coast may once have been inland. A plateau may be the top of an enormous volcanic story. A calm plain may hide flood channels below the soil. A bay may cover a drowned river valley. The visible world is only the current exposure, and the Earth's ability to hide older versions of itself depends largely on how quickly later processes can smooth over the evidence. Often, they smooth very well indeed. What is perhaps most remarkable is how often these ancient catastrophes were discovered indirectly. A strange layer in a core sample, microscopic glass spherules, unexpected minerals altered by shock, fossil pollen sequences that abruptly shift, a submerged forest revealed at low tide, a buried shoreline in seismic profiles offshore, huge gravel bars sitting where no modern river could have built them. Evidence comes in fragments first, and only later assembles into something large enough to call a catastrophe. That assembly process is one of the great intellectual pleasures in Earth science. The planet gives us clues in the wrong order, scattered across different disciplines, and expects us to compare notes. The result is that some of the biggest events in its past were not recognized immediately as such. They emerged slowly from pieces, as if the Earth had hidden not only the event itself, but also the shape of the explanation. There is also an important difference between something being hidden and something being gone. A buried coastline is hidden, not gone. An impact layer is hidden within rock, not gone. Water stored in minerals at depth is hidden, not gone. A drowned valley offshore still exists as a landform, though the sea now occupies it. A volcanic ash layer can remain traceable over huge distances, long after the eruption column itself has vanished into history. The world forgets in the living sense, but the Earth forgets more slowly. It stores outcomes. The challenge for us is that the storage is selective, distorted, and usually inconvenient. One has to dig, scan, core, compare, date, and argue, which is very scientific and also very human. We're forever trying to reconstruct events we were not around to witness, from evidence the planet preserved without any concern for neatness. And yet, that untidiness is part of the fascination. Hidden oceans remind us that the Earth circulates its own ingredients in ways that blur surface and depth. Buried worlds remind us that entire landscapes can vanish underwater, ash, sand, or sediment, while leaving enough behind to be rediscovered later. Ancient catastrophes remind us that change can arrive suddenly, regionally or globally, and that its traces may sleep in stone long after the event has passed from living memory. Put together, they make the planet feel less like a stable platform and more like an active editor, constantly writing over itself while somehow failing to destroy all earlier drafts. That also sets up a rather wonderful tension. If the world has hidden so much through drowning, burial, impact, eruption, and slow geological recycling, then many of the things we know today were not found because someone heroically marched out and pointed at the exact right hill with dramatic certainty. More often they turned up because a cliff eroded, a core sample was taken, a reservoir dropped, a road was cut, a fossil weathered out, a sensor noticed something strange, or an older assumption failed under the weight of awkward evidence. In other words, many of the deepest things we have learned about this secretive planet arrived through accident, surprise, and discoveries no one fully expected when they first looked. If there is one pattern that keeps returning in all of this, it is that the Earth rarely hands over its hidden things in a neat and orderly fashion. We like to picture discovery as the result of a careful plan, a team of experts choosing exactly the right spot, deploying the correct tools, and uncovering precisely what they expected to find, only with better lighting and more funding. Sometimes it works that way. More often, though, the story starts with something smaller and stranger. A dog runs into a hole, a hiker notices a shape in melting ice, a construction crew digs where it was not supposed to get interesting. An oil survey picks up an odd signature. A field long assumed to be ordinary produces something very inconvenient for the existing theory. In other words, some of the things we have learned about this planet and the past it keeps were found by accident, or near enough, and even after finding them we still do not fully understand what exactly we are looking at. That should probably make us a little more modest. Humans are very proud of our organised knowledge, and not without reason. We have methods, instruments, archives, laboratories, and the admirable ability to spend 20 years arguing about a single tooth, if the tooth happens to be important enough. But chance still plays a larger role in discovery than we often like to admit. Earth's hidden record does not emerge on schedule. It appears when erosion reaches the right layer, when weather strips the right patch of sediment, when a drought drops the waterline, when a quarry face opens the wrong hill, when someone notices that a thing previously dismissed as noise is in fact evidence. The planet is not trying to be mysterious. It is simply active, layered, and under no obligation to reveal its archive in the order most convenient to us. Perhaps that is why accidental discoveries have such a particular charm. They remind us that the world is still capable of surprising even people who thought they'd come outside for some other reason entirely. One of the most famous examples is the discovery of the Lascaux cave paintings in France, when a group of teenagers and a dog stumbled onto an opening in 1940 and found themselves in a painted underground world of extraordinary prehistoric art. It is hard to improve on that sequence from a storytelling point of view. Dog wanders off. Teenagers investigate. History becomes vastly more complicated. But what matters is not just the romance of the find. It is the fact that even now, after decades of study, we do not fully understand why those paintings were made, why those particular chambers were used, what the signs meant, how the images related to movement, sound, or ritual, and how the people who created them understood the space. We know a great deal more than the boys and their dog did on that first day, certainly. But the cave did not surrender a full explanation. It surrendered a masterpiece and left us to puzzle over the rest. That pattern repeats everywhere. Ötzi, the Copper Age man found in the Alps in 1991, is another excellent example. Two hikers came across what looked at first like a modern body emerging from melting ice. That alone is the sort of thing most people would prefer not to find on a mountain walk. Nobody sets out for fresh air thinking, perhaps today the glacier will return a 5,000-year-old murder mystery. And yet that is more or less what happened. Once studied, the body turned out to be one of the most important human archaeological finds ever recovered from the ice. His clothing, tools, injuries, diet, tattoos and final movements provided extraordinary detail about life in Copper Age Europe. But even with all of that preserved evidence, questions remain. What exactly led to his final conflict? Who shot him? Why was he where he was? Was he fleeing, travelling, returning, carrying out routine movement through the pass, or some mixture of all of those things? The accident of discovery gave us remarkable access to one life. It did not give us a complete script. There is something almost typical about that. Earth is very good at preserving clues, and rather poor at preserving the surrounding explanation. A body survives. The final conversation does not. A painted chamber survives. The meaning of the images does not. A buried wall survives. The local politics that made the wall necessary are usually less cooperative. This is not a failure of science. It is simply the nature of the archive. What survives into the present is not the whole event, but certain durable pieces of it. And when those pieces are found unexpectedly, they often open a door into questions much larger than the accidental moment that revealed them. One of the more striking examples of accidental discovery changing the human story is Denisova Cave in Siberia. The cave itself had long been known, but the world-changing part of the story emerged from the close study of a small finger bone fragment and a few teeth found during excavation. There was nothing dramatic about the object itself. It was not a golden mask, a monumental inscription, or a skeleton posed in tidy anatomical clarity. It was a fragment. Yet from that fragment, and later from DNA, researchers identified an entire population of ancient humans previously unknown to science, now called Denisovans. That is a wonderfully humbling sentence if you stop to think about it. A whole group of humans, not a myth, not a legend, not a mistaken rumour, but real people who existed and interbred with other human groups, effectively hidden from our understanding until the right tiny piece of bone met the right analytical methods. Earth had been keeping that secret in a cave drawer, apparently waiting for genetics to catch up. And even now, Denisovans remain only partly understood. We know they existed. We know they were related to Neanderthals and modern humans in complicated ways. We know traces of their ancestry persist in some populations today. We have clues about where they ranged, though likely farther than the sparse fossil record alone would have suggested. But the fossil sample is still frustratingly small. We do not have a neat, complete portrait. We have a presence assembled from fragments, a human population rediscovered almost by accident, and still emerging in outline rather than full detail. Which is exactly the sort of thing this planet does so well. It lets us glimpse the edge of a much larger picture and then calmly refuses to hand over all the missing pieces. The same could be said for the Chicxulub impact structure, though here the accidental element came through geology and industry rather than hikers or teenagers. The buried crater beneath the Yucatan Peninsula was not first recognized because someone stood in a field and announced that the ground had an asteroid problem. It emerged through geophysical surveys and the investigation of odd signatures associated with petroleum exploration, followed by the broader scientific work connecting impact evidence to the end Cretaceous mass extinction. That is a deeply Earth-like way to reveal one of the most consequential events in life's history. Not through a dramatic, visible crater, helpfully left pristine for us to admire, but through buried structure, shocked minerals, chemical anomalies, and a chain of reasoning that slowly assembled an ancient catastrophe from scattered evidence. Even now, despite the overwhelming importance of the impact, there are still active questions about timing, environmental consequences, interactions with other ongoing stresses such as volcanism, and the precise sequence through which ecosystems collapsed and recovered. We found the scar, but not every detail of the wound. There is a broad lesson here. Accidental discovery does not mean weak evidence. Sometimes it means the opposite. It means the world was holding on to something significant in a form no one had thought to seek in exactly that place, or under exactly those conditions. Science is full of prepared minds meeting unexpected facts. The important part is not that chance occurs, but that somebody notices the chance properly. A strange geochemical layer means little until someone asks why it is there. A fragment of bone is just a fragment until someone extracts DNA. A body in ice is a tragedy until it becomes, through careful study, a window into ancient life. The accident opens the door. Understanding still has to do the longer work of walking through it. That longer work is often where the deepest mysteries remain. Take cave art again. Its discovery may be dramatic, but its interpretation is almost always stubborn. We know prehistoric people created astonishing images deep underground. We know they selected certain animals and signs repeatedly. We know they used light, surface shape, and placement with considerable skill. But what the full system meant remains elusive. Were these places tied to initiation, memory, storytelling, hunting knowledge, spiritual practice, cosmology, or social identity? Probably not one simple answer for all caves, which is often the least satisfying possibility for people who like tidy conclusions and the most likely one for a species as inventive as ours. The accidental discovery of the site does not solve the deeper question of intention. It only forces us to admit that earlier humans were doing something richer than old stereotypes allowed. Sometimes the accident lies not in the first discovery, but in the re-evaluation of something overlooked. That may be even more unsettling, because it means the evidence was with us all along. A site gets recorded and misclassified. A fossil sits in storage under the wrong label. A landscape feature is dismissed as natural until better imaging reveals pattern. A cave deposit is excavated at a time when methods are too crude to extract its full significance, then re-examined decades later and suddenly becomes central. One of the quieter truths in earth science and archaeology is that many discoveries are delayed accidents. They occur because an older observation meets a newer question. The planet did not reveal something new at that moment. We finally noticed what it had already allowed us to have. This happens with human remains often enough to make anyone a little cautious about certainty. Bones from caves, partial skulls, isolated teeth, ancient DNA in sediment, all can overturn a settled story. Not because earlier researchers were foolish, but because knowledge grows unevenly, methods improve, comparative collections expand, dating becomes more precise. Molecular tools open categories of evidence that earlier generations could not access. A small scrap that once seemed too incomplete to matter becomes decisive. It is almost as if Earth understands administrative delay and has arranged its archive accordingly. We find the thing when we can, and only understand it when our tools are finally good enough to stop embarrassing us. There are accidental finds beyond bones and deep time too. Sometimes landscapes themselves reveal hidden structure under unusual conditions. Drought lowers reservoir levels and forgotten villages, roads, or building foundations reappear. Low tides expose old forests drowned by rising seas. Storms strip beaches and uncover trackways, ship timbers, walls, or buried surfaces. Wildfire clears vegetation and reveals earthworks otherwise invisible. Sinkholes open and expose chambers, tombs, or older voids below settled ground. None of these are planned moments of revelation. They are side effects of dynamic systems. A shoreline shifts, water retreats, sediment moves. The ordinary surface loses its grip for a while, and something older shows through. The difficulty, of course, is that sudden visibility does not guarantee comprehension. A footprint may appear, but whose was it, and from when? A buried building emerges, but was it domestic, ceremonial, defensive, or industrial? A chamber opens, but was it used once, repeatedly, or not by humans at all? A preserved body appears, but are the injuries evidence of attack, accident, ritual treatment, or post-mortem damage? Every accidental discovery arrives with a halo of uncertainty around it, and the halo can persist for years. That is not because scientists enjoy withholding satisfying answers for sport, though some people do seem professionally nourished by saying, it's more complicated than that. It persists because context is everything, and context is rarely preserved as generously as the headline object. There is also the uncomfortable fact that some accidental discoveries are already damaged by the time we notice them. A body emerging from ice begins to decay as soon as conditions change. A coastal exposure may last only a few tides or a single season before weather erases it. A site cut by construction may be destroyed almost as quickly as it is recognized. A fossil weathering out of a cliff may crumble if not collected promptly. A chamber opened accidentally may be vulnerable to contamination, looting, air change, or thoughtless handling. Earth sometimes reveals things only briefly, which gives discovery a faintly emergency quality. The hidden becomes visible, but only under conditions that may also threaten it. This is one reason researchers can appear both delighted and alarmed at the same time. It is because they are. Some finds remain unresolved not because evidence is lacking, but because the evidence allows more than one explanation. That can be maddening in the most educational way. A site may preserve unusual architecture whose function is debated. A pattern in the landscape may be deliberate or natural, or some irritating combination of both. A sequence of marks may be symbolic, practical, or both. Ancient DNA may show contact without telling us much about the social reality of that contact. A skeleton may preserve trauma without revealing motive. A crater may indicate impact, while the exact sequence of environmental effects remains contested. In such cases, the accidental discovery does not lead to certainty. It leads to better questions, which, to be fair, is often how real understanding grows, though it is less convenient for people hoping the Earth will kindly stop being so complicated. There is another category of accidental find that deserves attention: discoveries that force us to reconsider scale. A few ruins in a forest become, through broader survey, evidence of a vast urban network. A small cave assemblage becomes proof of a wider human population. A local ash layer becomes tied to a regional eruption of major consequence. An odd geophysical anomaly becomes the signature of planetary disaster. Earth often reveals its secrets in miniature first. A clue looks small until it is recognized as the edge of something much larger. That, perhaps, is one reason accidental discoveries feel so powerful. They remind us that the hidden world is not only concealed, it is disproportionate. Tiny signs can point to enormous structures of knowledge waiting behind them. There is a mild comedy in this too. Humans like to think of ourselves as the sort of species that goes looking in the correct place with clear intention and a measured confidence. In reality, some of our greatest breakthroughs begin with a dog chasing the wrong thing, a body mistaken for a modern casualty, a survey line run for commercial reasons, or a cave fragment too small to impress anyone until the lab work returns. The Earth is not mocking us exactly, but it does have a way of revealing that our control over discovery is partial at best. We prepare, yes. We search carefully, yes. But chance keeps a seat at the table. Not as magic, not as destiny, just as the inevitable result of living on an active planet whose archives are unevenly exposed. And perhaps that is exactly why we still do not fully understand so many of the things we find, because we are often entering the story in the middle. We encounter the preserved remnant after time, chemistry, burial, erosion, disturbance and coincidence have already edited the scene. We do not get to watch the event unfold. We get a residue, a record, a trace, a body, a fragment, a pattern, a scar. Then we work backward with tools, arguments, comparisons and patience. Sometimes the answer becomes clear, sometimes it remains stubbornly incomplete. The Earth, after all, is not a witness trying to help. It is more like a vast storage system that occasionally drops a box on the floor and lets us sort through the contents. Still, there is something encouraging in the pattern. Accidental discovery means the hidden world is not exhausted. We have not tidied up the planet's archive. There are still clues emerging from ice, shorelines, caves, quarries, deserts, forests and seabeds. There are still samples in drawers waiting for better methods. There are still anomalies in data that will later turn into accepted knowledge. There are still places where the surface looks settled and ordinary, while beneath it lie answers nobody has yet framed correctly. That should make us careful, certainly, but also curious. Not every surprise will overturn the world. Most will be smaller, more local, more technical. Yet history suggests that even those modest surprises can matter far beyond their first appearance. Which leaves us with a final and rather tempting question. If so many important things emerged only when accident, timing, and the right tools finally aligned, then perhaps the strange feeling we have had throughout this journey is not entirely misplaced. Not that the Earth intends to keep secrets in a personal sense, but that revelation on this planet is often conditional. Things appear when erosion reaches them, when ice releases them, when science matures enough to read them, when the surface stops hiding them just long enough for us to notice. And once you start seeing that pattern, it becomes very hard not to wonder whether some of the greatest hidden things are not simply waiting to be found, but waiting for the moment when we are finally ready to understand what they are. There is a tempting thought that begins to appear once you have spent enough time looking at the history of buried cities, cave paintings, drowned landscapes, fossils weathering from cliffs, bodies released by ice, and clues found by accident in places nobody expected. It is not a scientific theory exactly, and it is certainly not the sort of statement one would engrave onto a laboratory wall unless one wanted the funding committee to become a little nervous. But it lingers all the same. What if the planet reveals things only when we are ready? Not ready in the mystical sense, as though mountains are convening in secret to evaluate our moral character before releasing a well-preserved Bronze Age sandal. Not ready because the Earth is making judgments, selecting audiences, or waiting for us to pass some final examination in wisdom, maturity, and proper respect for sediment. The rocks do not hold meetings. The caves do not whisper, perhaps next century. The sea does not keep a diary of our progress as a species, but there is another kind of readiness, one that is entirely real and shows up again and again in the history of discovery. Sometimes the hidden thing can only be found when the right tools exist. Sometimes it can only be understood when the right questions are finally being asked. Sometimes it remains invisible, not because it is deeply concealed, but because no one yet knows how to recognize what is in front of them. That kind of readiness is not dramatic, but it is powerful. It means that discovery is not just about exposure, it is about interpretation. A fossil in a cliff is only a strange shape until someone understands anatomy well enough to know it matters. A burial is only bones in the ground until methods exist to date it, study the chemistry, analyze the DNA and place it into a larger human story. A patterned landscape under forest canopy is only terrain until remote sensing reveals roads, terraces, reservoirs, and planning on a scale that changes the meaning of the entire region. A layer of unusual sediment is only dirt until someone realizes it records flood, impact, tsunami, drought, or collapse. In that sense, a thing may be technically visible long before it becomes truly discoverable. Humans often dislike this because we prefer the feeling that truth is immediate if only we are clever enough. We like the image of a brilliant observer seeing what no one else saw, and certainly individual insight matters, but the history of knowledge is full of slower moments. A clue appears. It is noticed, sometimes collected, sometimes filed away, sometimes half understood. Then years later, or decades later, new methods arrive. Another find appears somewhere else. A comparison becomes possible. A suspicion hardens into a pattern. Suddenly the clue is no longer isolated. It becomes part of a much larger structure. The truth was not absent before. We simply were not yet equipped to assemble it. You can see this in the human story very clearly. There were times when ancient bones could be found, and their significance still remained blurred because there was no framework yet for deep human time. There were periods when cave art was doubted, underestimated, or misunderstood because the prevailing idea of ancient humans was too narrow to allow for such sophistication. There were landscapes that looked wild until technologies like LIDAR showed that they had once been heavily managed, settled, and engineered. There were fragments of DNA hidden in sediment, in tiny bones, in old remains, waiting for the development of methods sensitive enough to recover them. The planet had not changed. The evidence was already there. What changed was our ability to read. That is one reason the idea of readiness feels so compelling. It gives a shape to the pattern without requiring us to pretend that the Earth itself is choosing the moment. The moment is created by an alignment. The evidence survives. The conditions expose it. The tools mature. The minds looking at it become more flexible. Then, and only then, does the hidden thing become legible. It is a little like language. You can stand in front of a text written in a script you do not know and be fully aware that it contains information. You can even admire the form of it, but until you know how to read it, the message remains unavailable. Much of Earth's history has been like that. Visible, present, often physically close, and yet inaccessible because the necessary literacy had not yet been developed. There is also another kind of readiness that matters, and it is less technical. It has to do with humility. Scientific progress is often described as the accumulation of knowledge, which is true, but it is also the gradual loosening of certainty. The more carefully we study the Earth, the more often it turns out that our earlier, cleaner stories were missing important complications. Human history was not as linear as once imagined. Ancient environments were not as simple. Civilizations were not as isolated. Extinction was not always abrupt in the same way across every region. Climate change in the past did not always produce the same local outcomes. The deeper we go, the less the planet resembles a neat textbook summary. It becomes more tangled, more regional, more layered, and more willing to embarrass confident assumptions. That matters because readiness is not only having the right machine, sometimes it is having the right attitude. If you are too sure that a forested landscape could not have supported large urban populations, you may fail to recognize the evidence even when it is present. If you are too sure that ancient humans of a certain period were incapable of symbolic behavior, you may explain away or ignore signs that do not fit your model. If you're too sure that a coast has always been where it is now, you may overlook the drowned worlds offshore. If you're too sure that a region was marginal, empty, or secondary, you may miss the infrastructure hidden in plain sight. Readiness, in this sense, means being willing to let the Earth be more complicated than the categories we arrived with. And perhaps that is why so many of the greatest discoveries feel like corrections as much as revelations. They do not simply add something new, they expose something limited in the old view. A buried city under jungle is not just a lost city. It is a challenge to what later observers assumed about the scale of life there. A new hominin identified from a small bone is not just a new branch on the family tree, it is a warning that the tree was drawn too simply to begin with. A hidden water system deep in minerals is not just an interesting fact about the mantle, it is a reminder that our image of Earth as a simple layered shell was too tidy. The hidden thing appears, and at the same moment our former confidence becomes less comfortable. There is something healthy about that. It suggests that readiness is not a final state we achieve once and for all, but an ongoing discipline of becoming less easy to fool. Not impossible to fool because the Earth still has plenty of ways to surprise us, but less likely to mistake our current map for the complete territory. That may be the most useful lesson hidden things give us. They remind us that knowledge is strongest when it remains adjustable. The surface of certainty needs to stay a little loose, because sooner or later some cave, cliff, glacier or seabed will offer evidence that the older version was incomplete. At the same time, there are reasons to be cautious with this idea. "We weren't ready" can sound flattering, as though history has been patiently waiting for our special generation to arrive, with the proper mix of ethics, lasers, and grant funding. Reality is less flattering and more practical. Many things were found because of chance, industrial activity, damage, erosion, or climate-driven exposure. Some discoveries happened not because we were wise, but because the conditions preserving the evidence had begun to fail. Ice released ancient bodies because the climate warmed. Coastal erosion revealed old settlements because the sea was actively tearing them away. Drought exposed drowned villages because reservoirs fell. In such cases, readiness is mixed with loss. The thing becomes visible at the same moment it becomes vulnerable. That creates a more serious version of the question. What if the planet reveals things not only when we are ready, but when we are in danger of being too late? That pattern appears often enough to be uncomfortable. The hidden site emerges because the surface that protected it is breaking down. The fossil weathering from the slope is now at risk of crumbling. The cave environment changes once air, light and human traffic increase. The submerged structure is exposed only briefly by shifting sediment. The body in the ice begins to decay once released. The archive opens because its seal has failed. In those moments, readiness cannot be merely intellectual. It must also be practical. Can we document quickly, preserve responsibly, and study carefully enough before the newly visible evidence is damaged or destroyed? This is one of the quieter moral pressures in earth science and archaeology. Discovery is not always a triumph in the cheerful sense. Sometimes it is an emergency. A site found during construction must be assessed under time pressure. A fossil bed newly exposed by erosion may need rapid protection. A heritage landscape emerging under drought conditions may be looted if attention comes too fast and management comes too slow. A sacred place made newly visible by environmental change may require consultation, restraint, and respect, rather than a stampede of excitement. Readiness, then, includes something more than curiosity. It includes responsibility. If we are going to ask the Earth to show us what it has held for so long, we ought to be prepared to behave well when it does. That is not always our strongest skill as a species. We are excellent at finding things. We are somewhat less consistent at caring for them, and occasionally terrible at resisting the urge to turn everything into spectacle, merchandise, or argument before we have even finished measuring it. There is a long history of objects removed from context, sites damaged by enthusiasm, bones treated as trophies, landscapes mined for sensation rather than understood as records. So perhaps the question of readiness is also a test of patience. Can we let a discovery remain partially unresolved without filling the gap with nonsense? Can we admit uncertainty without losing interest? Can we preserve context, which is often more valuable than the object alone? Can we accept that not every hidden thing was waiting to be owned, displayed, or simplified? The Earth itself offers no guidance on this point, which is probably wise. It simply continues doing what it does. Layers accumulate, faults move, glaciers retreat, rivers cut, dunes shift, forest grows, water rises and falls, rock weathers, minerals recrystallize, deep water travels through stone, A cave passage seals, then opens, a slope fails, a shoreline changes. Somewhere, even now, something is being covered that one day may matter very much to people not yet born. Somewhere else, something already hidden is beginning to emerge because the surface above it is thinning, melting, eroding, or collapsing. The archive is not static, it is active and unstable, which means the process of revelation is ongoing whether we feel ready or not. Still, there is comfort in the thought that readiness can grow. Humans are not the same investigators we were a century ago, let alone 5 centuries ago. We ask better questions in many cases. We are more aware of bias. We have better tools. We are more capable of seeing connections across fields that once worked in relative isolation. Geology talks to archaeology. Climate science talks to history. Genetics talks to paleoanthropology. Remote sensing talks to landscape interpretation. Oceanography talks to human migration studies. We have become better at understanding that the world does not divide itself according to university departments. The hidden thing under a forest may require lasers, pollen, ceramics, hydrology, and local knowledge all at once. The body in the ice may require archaeology, medicine, climate science, isotopes, botany, and forensics. In that sense, readiness has become more collective. The Earth's secrets are rarely solved by one discipline alone. That collaborative readiness may be one of the most encouraging developments of all, because it reflects the actual complexity of the world. A drowned landscape is not merely an archaeological site. It is also a sea level record, a sediment problem, a preservation challenge, a question of local memory, and a technical issue in marine survey. A fossil-bearing cliff is not just a source of skeletons. It is also a sedimentary environment, a taphonomic story, a climate signal, and a timing problem. The more we respect that complexity, the more likely we are to understand what we find without forcing it into a shape that flatters us prematurely. And perhaps that is the closest we can come to answering the question honestly. The planet does not reveal things because we deserve them. It reveals them when physical processes expose them and when our own capacities make recognition possible. But those capacities are not trivial. They include technique, patience, humility, cooperation, and the willingness to revise our stories. When those elements come together, the Earth's hidden record becomes more legible. Not complete, never complete, but clearer. A little more of the buried city becomes visible. A little more of the cave sequence makes sense. A little more of the fossil world acquires shape. A little more of the deep interior can be modelled with confidence. A little more of the drowned coast can be mapped. A little more of the catastrophe can be reconstructed from ash, impact debris, flood gravels, and scarred rock. What I find reassuring in that is the pace of it. The world does not give itself away all at once. It comes in pieces, and perhaps that is fortunate. If every hidden thing was suddenly visible, the result would not be enlightenment so much as noise. We understand by stages. We absorb by stages. We revise by stages. The Earth, whether by accident or by the simple mechanics of preservation and exposure, seems to work the same way. One clue first, then another, then a method catches up, then a theory loosens, then a larger picture forms. The hidden becomes not less mysterious exactly, but more responsibly known. And there is one final thought worth leaving with. Readiness may not only describe science, it may describe perspective. To study the hidden Earth properly is to accept that the ground beneath daily life is deeper than daily life admits. Beneath the road is soil, beneath the soil is older ground, beneath that are older sediments, older climates, older coastlines, older extinctions, older seas. Beneath the present city is older settlement, under that perhaps floodplain, under that perhaps something marine, under that the slow mineral and tectonic history of a planet still working on itself. The visible world is not false, it is simply shallow compared with the history supporting it. Once you really feel that, the planet becomes both more familiar and more strange. Familiar because it is still home, still the place of kitchens, weather forecasts, school runs, train delays, gardens, harbour walls, mountain roads, and ordinary afternoons. Strange, because all of that rests on a body of evidence, loss, burial, pressure, memory, and incomplete revelation far older and larger than our routines usually allow us to notice. And perhaps that is the quiet gift hidden things offer us. Not just excitement, not just mystery, but proportion. They remind us that we live on a world that has not finished speaking, and that our best role in listening is not to demand a final answer, but to become a little more capable of hearing the next one when it appears. So maybe the real question is not whether Earth reveals things only when we are ready, but whether readiness is the slow practice of learning how not to look away when the ground opens a fraction and shows us what it has been carrying all along. Because somewhere tonight, beneath a forest, under a desert wind, below a glacier edge, inside a cave wall, under a harbour floor, within a mountain pass, or deep in rock that no human will ever touch directly, the planet is still holding on to things we have not yet learned to read. And when they do emerge, as some of them certainly will, they are unlikely to make the world simpler. They will make it fuller, older, less certain, and more interesting. Which, for a restless species living on a patient planet, may be the closest thing to an answer we are ever going to need.